All right. Welcome. Please come sit down. Please sit towards the front so it doesn't look like it's not crowded. Thanks so much for coming out. My name is Joshua Hodge. I'm the director of the audio programmer. We've been doing this thing for about 6 years now, and I'm so proud that we're able to do this evening. Big thank you, first of all, to Chris Nash and the Point Blank team for having us this evening and for hosting us at this amazing facility. It's a brand new facility, and we're so proud to be here and collaborating with Point Blank. Thank you for coming out. I know some people have come from quite far away. And welcome. So just going to do a quick little blurb here. So first off, if you're getting into audio programming, I welcome you to check out one of our books. We've published 2 books over the past 2 years. One's called The Complete Beginner's Guide to Audio Plugin Development, and also creating synthesizer plugins with C++ and Juice. So for this weekend, we're going to be doing 20% off for both of these books. So if you're interested in getting into audio programming or taking things to the next level, come check us out. The link to do that is theaudioprogrammer.com/books. Please use the code API25 on checkout to get your 20% off. And we have a new series coming soon as well, just to let you know a little bit about that. So creating your first sampler. So one thing that we've done in the past is that we've done Juice tutorials from the bottom up. So teaching you how to do things like loading and saving state, how to get started with graphics. And so this one we're going to do a little something different, which is that we're going to teach you from the start, or from the end, and then go back to the start. And we got a little surprise for you. So for everybody that got the USB wristbands, we actually have the code base for this sampler on your wristband. So go ahead and check that out. We also have some other goodies, some exclusive tutorials, and we also have some exclusive stuff from Point Blank as well. So check out the USB bands. We have a lot of great stuff on there. And let me see here. There was actually a slide that it skipped. This isn't my computer, so I apologize. So let me just talk a little bit about what we do at the Audio Programmer. So we have 3 aspects to our company. So we are, first and foremost, a audio programming community. So we help people to learn to create their own audio apps and plugins. We also have a recruitment platform as well. So we've helped many companies to connect with the right talent for the right audio software developers, right managers, and right executives. And then we also have a development agency as well. So for creators and companies that are looking to create an entire product, we have an in-house team that's able to take you from the start to the finish. All you need to do is give us your vision, and we can create a product for you. What's that? Oh, yes. There we go. There we go. And I wanted to give a big shout out to our sponsors. So first and foremost, like I said, Point Blank, thank you very much for lending us your facility for the evening. They have a new software engineering course that Chris is going to talk about very shortly. It's excellent. Be sure to check it out if you're interested in getting into audio programming. Big shout out to Focusrite, who's been a longtime sponsor and supporter of the Audio Programmer. We're also sponsored by Sea Lion, who does an IDE. That's where you do your coding. And excellent IDE is what a lot of professionals use. A lot of great tools. They also have within the IDE itself, they have where you're able to confer with AI and LLMs. I know everybody's loving the AI these days. So you can use that right within the IDE. Also, a big shout out to the Juice team who are here this evening. The Juice team is in full force this evening, and Ruben from the Juice team will be giving a talk this evening on the MIDI 2.0 platform, and also to ADC, the Audio Developer Conference. So that will be happening in November. For more information, be sure to check out audio.dev. I'll be there. The audio programmer team will be there. And we hope that you will be there. And with that, I think I'll wrap things up. I'd like to welcome to the stage Chris Nash, who's the program leader for the Muse course. He'll be telling you more about that and giving his talk.
Well, thank you, Josh. So yeah, this is Dr. Chris Nash. My name is Luke, and really we wanted to quickly take this opportunity to tell you a little bit more about Point Blank and about the building that you're in here today. It's great to have you all with us this evening, and I wanted to just really kind of start off by giving you a bit of a brief background about who we are and how we got started. So Point Blank's been around now for just over 30 years. In fact, established and founded by this man over here, Rob Cowan, who's with us this evening. And originally we started off actually as a recording studio. The idea back then was that we wanted to make records, make music. Music technology wasn't as advanced and developed as it is today. And so a lot of people would come into the studios and ask a lot of questions about how all the equipment worked. And so we started teaching these guys and girls music production courses on the weekends. And these became incredibly popular and essentially was the nucleus of what Point Blank is today, and all of the amazing courses and higher education degree programs that we offer today. We're a global student or global kind of community with students all around the world. Our campus here in London, we've got one in LA, there's one in Ibiza where we teach summer courses as well as a whole range of online courses. And hopefully some of you have already heard of us before. If you haven't, do check out these courses. They're a great way of learning more about music production, DJing, software development, which we'll find out a lot more about today, etc. Incidentally, I'm also going to be doing a tour later on. So if anyone here this evening is interested in actually taking a look around all of our facilities, recording studios, come with me, come and find me. I'll be taking you around a little later on. You can have a little sneak peek. I wanted to talk to you a bit about our courses that we do. So alongside our music software development program, which Chris is going to be talking about a little later on, we also teach music production and sound engineering. It's very much where we came from, as well as DJing, radio broadcasting. We teach a vocal performance. That's better. I think the clip's broken on this, so whoever's next, hold it properly. So where were we? Our songwriting courses, as well as music business and the music software development. So if anyone here today is interested in any of these other courses, if you are music producers yourself, we do offer courses that start from the very basics and fundamentals, right up to much more advanced programs as well. So sound design, advanced sound design, mixing, mastering. We've just launched a spatial audio mixing course as well. So there's loads of cool stuff for you to come and learn. A big thing that we teach here at Point Blank are our degree programs. So we have a multitude of different pathways available from a foundation year through to Bachelor of Arts honours degrees in music production, sound engineering, DJ performance, vocal performance, business, songwriting, and the main one I think which might interest most people is the software engineering Bachelor of Science degree. We also do a Cert HE in radio, audio and podcasting. To talk to you a bit more about our Muse course, it's a Bachelor of Science, as mentioned. It's validated by Middlesex University, who we partner with. It's a 3-year traditional degree program, and we're actually offering a £9,000 scholarship to any student that starts the course with us that we pay to you, and that can go towards awesome equipment and helping you study the course. We've got our course starting coming up in October, and we're still accepting applications. So if there is anyone here who's interested, do apply. We're still accepting applications, and we'd love to consider you and hopefully see you on the course. Yeah, Chris is going to be telling us a lot more about it. I've got a quick video I'd like to share with you, just a bit more information about it, so check this out.
The music production and software engineering course, also known as Muse, looks not only at how we use technology in advanced ways, but how we make it.
Music software engineering is about creating tech products that are going to help people to create better music.
Musicians and producers and sound designers can make sounds that we've never heard before.
For me, being able to create music and be able to create the tools that are used to make music it just really excites me.
The ability to unite, for instance, visuals with lighting, with spatial audio, and developing softwares to connect those different environments. There's a whole realm of softwares just waiting to be developed. That's a huge market.
You will be in demand from a wide variety of companies that are looking for software developers. You can really be as creative as you want.
What's really powerful is to be in an environment where you're with other students and with tutors and technicians who brings so much information and such a body of knowledge for you to tap into.
They're going to have ideas. They're going to, know that there's something they want to create within music and within technology, but they might not know exactly how to go about doing that. And with that education, all these doors kind of open up.
What it gives you is the structure around yourself to put you in the best position to succeed.
Now would be the time to get into those technologies and start investigating them. There's nothing to stop an individual creating something that's equally as powerful as a technology company.
With the skills you'll learn on the course and the ability to code and make technology, you could be the one who has the next great idea, the next theremin, the next gestural control interface. It's literally possible on this course.
Thank you very much. Thanks to the team who helped make that video. In fact, Barney's here who made that video. It's awesome. Another thing I just quickly wanted to mention about studying the Muse course with us is for every student, we're also going to be giving them a Muse development kit, or MDK, which basically is crammed full of great goodies, as you can see up on the screen there. But basically everything you need to, start programming and coding and, developing software that you can imagine. So that's going to be given to every single student. So a nice little addition. And now I wanted to, pass over to Chris. Before I do, just remember, I'll be doing a tour later on. So if you are interested in checking out our awesome facilities, and they are brilliant, do come and find me. I'd love to show you around. Cheers. Thank you.
Cheers, Luke. Hello. The Muse course is something quite new. Obviously, there's been music computing courses in the past, music informatics, but this one is completely geared towards professional practice. It's about getting people who are ready to work in the industry, and it's quite a novel approach that we take. So that's what I'm going to be talking about. I'm the first speaker. I'm just going to give you a quick overview of the ethos behind the course. And there's music technology courses out there, but this is not just about using technology, this is about making technology. I'm sure this is something that excites everyone in the room. Obviously you've got DSP, you've got synthesizers and effects, and you'll pick up the advanced production skills as well in the first 2 years. But then basically as you move on, you'll actually pick up the best parts of a computer science degree, but entirely devoted towards audio software engineering. So what we try to do is a bit more. We don't just teach you how to make synthesizers and effects, but we'll teach you how basically industry works, how to quality assure things, what agile software development is, so that basically you are not just a graduate, but you're like a graduate with 1 year of professional experience. And we're getting industry involved, not only in the design of this program, but in the creation and the teaching of it. So in the third year, they'll come in, they'll teach the students about current practices, they'll give challenges for hackathons and things like that. And obviously, this is a fantastic opportunity to for industry to meet the next rising stars, and for students to obviously get a job. We've been working with a lot of different people in the industry who are basically telling us what they need, because it's very, very hard to find someone who's expert in audio, and someone who's expert in software, and someone who's expert in music, and someone who's expert in psychology for user interface design. So there's a little bit of all of that on the course, and it's specifically designed to produce Renaissance men and women who are expert in all these fields. So lots of different career trajectories. Obviously, audio software development, but artist makers as well. And we'll talk a bit about how we actually try to change the mindset of people on the course as well, to have you thinking differently about what music is and what audio is, so that you become a more versatile creator. So this is the Muse course. It's obviously in a very big font, but Don't worry, I'm going to drill down into mainly the first year, actually, because we've got a really innovative program, basically, that takes you from 0 to C++ in a year. And that allows us in the second year to go into advanced DSP and advanced techniques. And whereas other courses, if they even teach things like Juice, will wait until the third year, by the end of that second year, you'll be a capable developer. So that in the third year, you can be working on the cutting edge technology, AI, GPU audio, and you'll be learning about how industry works. So I'll talk about this in a second, actually. So this is completely different speaker. Hi. The first talk. So what I'm going to do in my first talk is basically talk about some of the techniques and some of the tools that we use in the first year to get people, started with programming. I don't know if you know this, but computing is in dire straits at the moment. People are disengaging from courses, and young people are finding it really, really challenging. Digital literacy has dropped, so we need to rethink the way that we actually teach. And which is why we've taken such an innovative approach here. Hopefully you'll agree. So I'm going to be talking about the first year, and I'm going to be talking about the tools that we use in the first year, which include Manhattan, which is a procedural music editor that we use to teach computational thinking. So changing people's mindset so that they actually are ready to learn C++, which comes along in the second module. And talking about some technologies in that module which allow people, well, it kind of smooths out the cliff edge learning curve that you get with C++ and Visual Studio and Xcode. About me, so I've got lots of different hats. I did a PhD in music software design at Cambridge, but that was mostly about studying the kind of psychology behind learning and creativity. So that's allowed me to design some interesting pieces of music software, which I'll demonstrate and I used in the course. Enables me to work out how to teach complex things like music and coding in different ways. And has allowed me to do lots of exciting projects with companies like Steinberg, Yamaha, and the BBC, for example. So what Muse is very different, okay? It's computer science remixed. And we're trying to make it more accessible. We're trying to bring in audiences that haven't got into computing before. And we're trying to adapt to kind of people who have never programmed before, okay? But we're also trying to get them far further along in the space of 3 years than you can on most music technology courses so that you are ready to be a professional. So yeah, no coding experience required, but you come out as an industry professional. But it's not a 3-year course, it's actually 3 stages of a 3-year course. So even that first year, you'll be a capable C++ developer by the end of it. And the second year, you'll have actually the skills to create almost anything in software, full applications and things like that. And then that stepping stone to industry in the third year. I'm going to talk about the first year, basically, which comes in 3 phases. We get you ready. We teach you programming through music. Then we thought, well, let's get C++ in at the second module. They're ready for that? Sure. We've got a slight trick there. And then at the end of it, all the rest of C++ and the Visual Studio. A couple of concepts. Who knows what flow is? Ever been in flow, absorbed in an activity? This is my PhD work, basically. So basically, if you're in flow, you're the happiest you'll ever be, and the most creative you'll ever be, and it's a great blueprint for learning. But if the challenge is too high, you get anxious, and if it's too low, you get bored. So the challenge now in delivering a degree like Muse is that the challenge of computing is very, very high, and young people, unfortunately, are less capable with computers because of controlled ecosystems. So how do we solve that? How do we keep people in flow, which is how do we make them enjoy learning? Well, we just make it a fast feedback loop. Okay? If they keep doing things and getting feedback on it, they feel in control. They get absorbed. So these are 2 concepts. If you want to know more about these concepts, I've given other talks at the ADC and Chime and things like that where I drill into these details, but just kind of bear these in mind with the tools and techniques that I'm going to show you. So I'm going to go through the first module, basically, which is computational thinking, which is basically learning to code through music, but also need to pick up on a few other elements of digital literacy along the way that they might not have encountered. So it's about thinking of music as, well, lots of different things, okay? And probably, everyone's in the room has thought about music in these different ways. Maybe you've not thought about thinking in these different ways, but this is what we encourage on the course. And in that first module, we're going to learn to code. We're going to use an environment I've developed called Manhattan, which is about procedural music. I'll give a demo of that in a second, where you'll pick up all of the ideas like loops and variables and arrays and things like that in a music environment, in a kind of context of musical creativity, but you'll also learn to think like a computer, okay? How computers work. So the Muse development kit is obviously a nice freebie, but we wanted to give them a computer that they can make their own, they can tear apart, they can upgrade, so that they actually find out how the hardware works, how they install operating systems, they learn command line, and they become a power user, effectively, something that is rarer and rarer these days, but I'm sure you'll agree is critical to a professional practice in audio software development. So we'll have masterclasses on this alongside coding in Manhattan, and we'll teach them how to think analytically, not just about code, but the whole world. Think about music as patterns and processes rather than just notes on a page. So that's the Muse development kit, and so you've got a little mini computer there. They'll have to tear it apart, upgrade the RAM, upgrade the hard drive and things like that, install the operating system, make it their own, dig about with it. If they break it, they'll learn. And an I/O device. So this is a programmable I/O device that they can actually, decide what it's going to be. They can program the mappings, the inputs, the outputs, and it's capable of being a MIDI controller or a keyboard controller. But the idea is that they think about interaction, input, output, and they'll be playing around with kind of like, command line again and copying across firmware and mappings. And again, if they break it, they learn. So let me give you a quick crash course in Manhattan. Who's ever used a tracker? Good. Sound trackers, renoise and all that. If you go back far enough, Octamed, maybe, fast tracker. Oh, yes, some hands. Fantastic. Yeah, it's a musical spreadsheet. I know that. And they've been around for ages. And yet no one had the idea to put Excel formulas in the cells. I thought, well, I'll give it a try one Christmas. And that's what Manhattan is. Manhattan is a procedural music environment, which is effectively a sequencer, where the notes and events can also be code fragments. So they can decide what the note's going to be as they're being played. They can be based on previous notes and things like that. It works a lot like Excel. So it has that very, very low threshold for getting into it, perfect for a first-time programming experience. And it's flipped, right? One of the terrible things about programming is you don't see the data. Okay, you see the process, and that's not great for learners. So in Manhattan, you can see the notes and the data, and you write the code in the background, and you can see exactly what happens to the code. So lots of visualizations about how your code is affecting the song. But it's not just a toy. It's not just musical Excel. It has a low threshold, but it also has a high ceiling. So I'm going to show you a couple of examples of what students actually get up to, and also some of the applications for procedural music in general. Because when you can represent music as not only process, but patterns, well, you can pretty much encode any type of music for any circumstance. The name Manhattan, everyone asks, it's not the Manhattan Project you're thinking of. It's the grid distance, basically. So in computing, up, down, left, right is Manhattan. So it's a weapon of mass creation, not destruction. One of the really key things for those people who might have dabbled in procedural music is it's got a linear idea or non-linear idea of time, in that time actually is represented. So you can address future and past events and things like that. Makes it a very powerful way of mixing traditional composing with procedural and generative elements. Right, here we go. This could be interesting. This is Manhattan. So as you can see, it looks a lot like a spreadsheet. And why I'm mentioning it now is because we use it on the course, and because inside the program it has a full computer science curriculum that goes through almost every idea in computing and programming through famous pieces of music, which you have to complete with code. So I'm just going to do something quickly now. I'm going to move Pachelbel's canon from 1692 to 1992. Loud. And that's a little skippy. Big. Right, the most exciting cello part ever written for a cello. So let's not actually listen to that. I'm going to go to this cell over here, blank panel, and I'm going to say the pitch for this cell is going to come from channel 0. So we're going to take that cello part, take its pitch, and bump it up 12 semitones, which did not work because it's not channel 1, it's channel, there we go. Okay, don't know why it's glitching. And then I'm going to basically harmonize that. Okay, so what we're teaching is kind of music as maths. Okay, and we're starting, this is one of the early lessons. This is kind of one of the really easy ideas that you can add things together, numbers together to get beautiful harmonies. So, going to do the same again, but I'm just going to basically take that channel and add 4 semitones, and take the same channel and add 7 semitones, and then once more onto the breach with 11 semitones. Copy those cells and their formulas. So yeah, almost 1992. What's missing from 1990s? It's lesson 3. Yeah, I've effectively taught pointers in lesson 3. That's going to go well. Right, so there's a full computer science curriculum in there. Spend a few weeks to program, learn the language, and then students are capable of turning almost any piece of music into code, and the results are quite incredible. So download the program. It's on Steam. It's called Manhattan, and that comes with some of the student work in it. I'm going to play you one student piece. Here we go. But yeah, all types of music. It's not just 4 on the floor. Okay, so just briefly, some other applications of procedural music that Manhattan supports as a plugin for Unity and soon Unreal. So here we go. Once you integrate the game with the soundtrack so that the game has note-level access to the soundtrack, well, you can have a lot of fun. This is a defend the castle bow and arrow type game with the orchestra in it. The orchestra playing each of the notes. They do all the usual things. More instruments play when bad guys turn up. And it's part generative and part sequence, so you can put melodies in there. And where's the fun bit? They're mortal. Obviously, you can remove instruments from a soundtrack. But can you make them play worse? Ooh, what's that barrel? It's very close to the orchestra. It's a very brave orchestra. They're related to the guys on the Titanic, I think. I don't. Thank you very much. So this is just a sneak peek, very quickly, of a game I'm working on in Unreal, which is basically Britain, the video game, and I'm basically recreating the entire country. So the music here is procedural. It's been generated, so if you watch the video on repeat, it's different every time. It's amazing the data that's out there. But these are just some of the ideas that we try to open students up to, in thinking about music differently, thinking about how music might be different itself in a few years' time. It might be live, it might be dynamic. But yeah, if you want to know more, come to my ADC talk this year in Bristol. And yeah, there should be a playable form of it at the ADC as well. Cool, right. Next module. Where am I? Here he is. Right, they're ready for C++ now. Yay. So yeah, this module, we also actually do as a short course. So this short course is basically 10 weeks, 10 plugins, even if you've never coded before. We've actually got some alumni in the audience. And you can see that actually there's quite a lot in there. And we lie, actually. It's more like 40 plugins. How do we do that? How do we get them into C++? They're making these plugins and learning C++ at the same time. Well, the trick is Clang. Okay, Clang is my language. It's not really a language because it's actually C++. So Clang is a single header include that you can add to any C++ project to give yourself audio syntax and audio semantics, including things like signal flow. And the idea is to reduce the threshold of C++ without moving away from C++, so that you still actually, because it's native C++, you can then compile it anywhere, you have all the performance, and so you don't learn something that's going to be obsolete once you become a professional, because you're learning C++. And you see here the block diagram on the left, nice and simple. It looks like a wah-wah effect or auto-wah effect. Translates to the code on the right pretty linearly. And you can see I've overloaded the stream operators so that you can represent signal flow. But that is completely C++. So it's a great way of making your audio processes more concise, being able to read them as audio processes rather than lines of impenetrable C or C++. It's open source, it's a single header, so if you want to play around with it, it's on GitHub. Yeah, job done, right? C++ easy. Nothing else that's tricky. Oh, except for the environments that we edit C++ in. Okay. Okay, put your hands up if you are a Visual Studio or Xcode user. Okay, keep your hands up if you know what absolutely every feature in those programs does. No, I didn't think so. Oh, hang on, there's one. Oh, it's just a slow hand. Right. So in addition to the kind of reducing the complexity of C++, we put the C++ IDE inside a DAW plugin. You're just your standard synthesizer plugin. Oh, wait, it can be resized. Ooh, it's got some nice pictures. Oh, it's got a button called Edit C++. It's got a whole Clang with a C toolchain in it, so that in a VST or an audio unit, you can actually edit the C++ code of the plugin you're running. So this is absolutely amazing for teaching students. It turns out to be pretty amazing for just prototyping code, because you can make a change to a single line, click build, and say, oh yeah, that's the sound I want. So this is the pillar of the audio processing module and audio programming short course. And it basically allows us to teach people how to develop 40 plugins in 10 weeks or 40 hours. Yeah, so I don't know how much time I have. Not much, right. Then I will leave you to try Clang. It is free. It's on my website, nash.audio/Clang. But if you want a guide to installing it and actually coding audio programming, we have literally just released a plugin boutique short course, 4 plugins in 4 hours, which gives you a flavor of how we do things at Point Blank. And so it gives you, for example, what we do with the virtual learning environment, a custom virtual learning environment, which is incredibly visually driven, runs web audio, the plugins you'll develop, and you can actually edit C++ and compile code inside the VLE itself to learn kind of concepts in isolation. Have a try with it. The first module is actually for free. Just basically see what we're doing and how we're doing things slightly differently here on Muse. So yeah, and that's pretty much me. And that's also how we get people from zero code to C++, because by the end of that course, people were already teaching themselves Juice and not scared of it anymore. Please do talk to me throughout the evening if you have any questions about the course. But otherwise, thank you very much.
Yes, give it up one more time for Chris Nash. Woo! Okay, another quick announcement, just in case you're not aware, we have some pizza that's going to be coming a little bit later, so I'm sure some of you may be getting a little bit hungry. So we have that coming a little bit later. In the meantime, we're going to go ahead and have a little short break while our next speaker, Ruben Thomas, is going to come up to speak about MIDI 2.0 and Juice. So Ruben, can you please come up to the stage? Please have a moment amongst yourselves. One thing that I wanted to mention while, go ahead, come on up, Ruben. One thing that I wanted to mention is that we have a great mixture of experienced experienced people within the industry, as well as people who are looking to get into the industry. So if you're experienced in the industry, I encourage you, please take some time to get out of your bubble and speak to some of the students, some of the people that are looking to get into the industry, let them know a little bit more about what it's like to work within music technology, and vice versa. If you're a student, please don't be shy. Please feel free to engage with anybody in here. The industry is very welcoming. And I encourage you just to get out of your shell, meet new people, and have fun, connect. So yeah, go ahead and just have a short little break, just maybe 2 or 3 minutes, and Ruben will be with you shortly.
Maybe you're the one, you're the one. I feel like I'm walking the tightrope of love in your circus play. If I were to fall, it'd be my last day. Even though you're right under me, so I'ma take my time. Go with the flow, can't get to and fro. You gotta face that. Just can't say no to. Just can't say no to you. You know I want you, baby. You know I do. I'll give you my heart and the rest is up to you. You ain't no good for me. I know it's true, but you don't have to be. 'Cause I do it for the thrill, for the rush. I do it for the pain. You're the one. You're the one.
Ready for the next presentation.
can't see anything. Sorry? I know. I can't see anything. Is everyone ready? I'm blinded by the lights. Hello, hello. I'd like to introduce you to our second talk, which is by Ruben Thomas from the Juice team. Ruben has worked on the Juice team since 2020 and been a lead engineer since 2023. His contributions include an implementation of MIDI 2.0, compatibility inquiry, LV2 hosting, and client support, as well as CMake build system integration for Juice projects. And give him a very warm welcome. Oh, sorry.
Hello, hello. Okay, yeah. Today we're talking about communicating with MIDI 2 devices. Can I get just up top a show of hands if you've used Juice before? Cool. Okay, great. This is the right room. And have you heard of MIDI 2? Okay, good, 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 good. Okay, you've already heard a little bit about me. I work on Juice. I've done that for a while. I was a Juice user for a few years before that. And during my time, I've written quite a lot of MIDI code. And that includes most of the code that we're going to look at later on today. So let's start by taking a bit of a step back and examining what do we actually mean by MIDI 2. And there's maybe a bit of a misconception here. MIDI 2 isn't really just one thing. It's more two broad categories of features. So one of those we just heard about is capability inquiry. And this is a feature that sort of provides standardized messages or ways for devices to advertise and configure their functionality. So on top of capability inquiry, there are two more sort of sub-features, one of which is profiles, which is a standardized operating mode. So something like a piano controller or a drum kit controller might implement a profile so that other devices know what kind of note events they might expect from that controller. Or similarly, a synthesizer with orchestral articulations and orchestral sounds might implement a profile so that other devices know that those articulations and sounds are available. There's also a property exchange, which is a way to get and set device properties. So an example of how you might use that is to display parameter names for parameters next to hardware encoders on your external keyboard or synth hardware. So Juice has had capability inquiry support for a while. If you're interested in this, making use of it, there's a whole module dedicated to it called Juice MIDI CI. There's a demo called the Capability Inquiry Demo in the Juice repository. And this works over standard, normal MIDI 1 connections. So you can use this today with existing hardware as long as both devices that are connected know that they're, or at least one of them has capability inquiry support. So we're not talking anymore about capability inquiry today. What we're talking about is the other sort of broad category of MIDI 2 feature, which is called the Universal MIDI Packet, or UMP, because that's a bit of a mouthful. And this is a whole new format for MIDI messages. So it's capable of representing MIDI 1 messages with no loss of information. But also, we have extra room in each message. So messages are larger, they're more descriptive. And we have entirely new kinds of message available as well. So today we're going to be talking about some functionality that's enabled by this new MIDI format. What kind of functionality is that? So again, there's two broad categories of things. One of the features you might be interested in is high-resolution MIDI 2 channel voice messages. So these are new MIDI messages with higher resolution for things like velocity and pitch. The other category is new categories of messages to get and set information about devices. This might sound a little bit like the property exchange feature I just mentioned, but this is generally for lower level properties of devices. So this is for things like configuring the connection itself rather than adjusting behavior of musical functions on the device. So we're going to do a very, very quick tour through UMP now. On the left here, we've got a diagram of some MIDI 1 messages. On the top, we've got like a note on, which is 3 bytes. We've got an aftertouch message, which is 2 bytes, and then sysx, which can have any length. On the right-hand side, we've got UMP format messages, a very sort of vague overview of them anyway. So you can see right out of the gate, we've got a lot more room in each message to play with. So messages might be 4 bytes long, all the way up to 16 bytes long. So we've got at least 1 extra byte per message relative to the largest MIDI 1 message. And for the most part, we make use of this byte by adding 2 extra message fields. So we've got this new message type, and we've also got a group for each message. Each of those is 4 bits, which means that we have 16 possible message types and 16 possible groups for each message. And the length of the packet depends on the message type. So all messages of the same type have the same packet length. So if you want to convert your MIDI 1 messages into UMP, generally it's a pretty straightforward process. You're just adding this extra byte at the beginning of each message and then padding out to 4 bytes. So we, because it's a MIDI 1 message, we say that the type is 2, and then we have this entirely new group field to play with, and then everything else is just copied across from our MIDI 1 message. sysx works a bit differently because it's variable length. That's not too interesting or important, so I'm going to gloss over that for now. The important bit to keep in mind is that we've got this whole new group field. So what does having a new group actually mean? What's the significance of the group field? Well, groups end up acting like an extra level of organization above channels in your MIDI message. So as well as the 16 channels that your message, your channel voice message might fall into, we also have 16 groups, each of which can hold 16 channels. So we have a potential for 256 channels of note information in total. So in a way, a single UMP connection is a bit like 16 MIDI 1 cables all bundled together. So you're getting 16 times the data throughput. It's also worth mentioning that not all messages have a group, so you can also address messages directly to an endpoint in order to send or receive data that refers to the entire endpoint. So we use these new groupless messages in order to implement device discovery, which is a new process over MIDI 1. So when 2 devices are connected, ideally, in an ideal world, we'd like them to be able to talk to each other and configure themselves intelligently. And device discovery is sort of the first step towards that utopian dream. So when 2 devices are connected, one device will ask for some information, the other device can respond. This implies that MIDI connections in a UMP world are bidirectional. So all of your devices will normally have an input and an output, rather than MIDI 1 devices today, which normally, like if it's a synth, might just have an input, or if it's a controller, might just have an output. And we can use device discovery to report lots of information that we weren't previously able to retrieve over MIDI 1. The bits that I want to call attention to here are the supported protocols of the device and the device topology. So firstly, protocols. We've already seen that UMP can carry MIDI 1 messages. But I've also mentioned that MIDI 2 has support for this whole new set of even higher resolution messages, MIDI 2 messages. So discovery is a way for us to be able to find out which protocols a device can support, and then also select a profile once we know that high resolution messages are available. In terms of topology, I've already mentioned that we have 256 possible MIDI channels now, but that's probably overkill for most musical functions. Generally, you don't need that much polyphony all on one musical device. And at the same time, many synthesizers and hardware devices have multiple different functions, like they might have hardware MIDI inputs and outputs, or they might have controllers and multiple sound engines. So we want some way of finding out what functions are available on a given device and talking to each of those functions separately. So the way that we accomplish that in MIDI 2 is we have this concept called a function block, which it represents a unit of functionality on the device. So if you imagine a synth with a drum engine and an orchestral engine and then a couple of hardware inputs and outputs, each one of those entities might have its own function block. Function blocks are optional, they're not mandatory, but they're highly recommended for better user experience so that your users can actually see what functionality is available on their device rather than just having to manually route 256 channels separately, which I wouldn't wish on anyone. Each block has a bunch of additional information that is available. And well, you can see it there. There's a total of 32 blocks for each device, and each block can hold one or more groups. So now we know all about UMP. We can go and write UMP parsers and creators. But importantly, we know about the UMP format, we know about groups, and we know about function blocks. So next up, I'd like to talk about some changes we've made in Juice in order to support these new features that are available over the UMP format. So the requirements that we have for the work in Juice, we want to be able to list available devices. So this should be devices that support UMP, but also older MIDI 1 devices, so that we have one unified API that you can use to talk to any MIDI device. We want to be able to take some kind of action when devices change, when they get plugged in or unplugged. We want to expose all of the new information that's now available from the discovery process, such as the function block configuration. And we want users to be able to read and write messages in UMP format, even when they're talking to MIDI 1 devices. And again, this is so that you can just write all of your code once in UMP and then talk to new MIDI 2 devices or existing MIDI 1 devices without having to change any of your code. And finally, we want to expose some way of creating a virtual UMP device that you can expose in your programs so that you can talk over UMP to other UMP-aware applications. Quick disclaimer here, we're going to look at some code snippets, hopefully nothing too scary. This is all sort of pre-release quality, so there might be small changes before this goes and gets set in stone, but hopefully not. And all of the new types that I'm going to talk about are in the UMP namespace, but I've left that off the slides just to keep things concise. So we're going to start off by trying to look for some connected devices, and the way we do that is through this object called endpoints. This is a singleton, and it's going to cache all of the MIDI devices on the system. And it's also responsible for emitting notifications when that list of devices changes. So to find out what devices are connected, there's a pretty simple function we just call getEndpoints. This is going to return a vector of identifiers for each of the devices that we know about. And it's important that these are identifiers. This isn't any further information. This is just a unique ID for each endpoint. To find out actual information about each of those devices, we can pass one of those IDs to getEndpoint. And this is going to return on success a struct with all of the information that we know about that device. So that will include things like the name, the protocols that it supports, the protocol that's currently active on the device, the full function block layout. And on failure, this is going to return a null optional. So a failure case might be if we're passing an old ID into this function for a device that's been disconnected since we enumerated the devices. So this function is going to return all information that's available through the discovery process that I mentioned earlier. But we also know from the OS a little bit more information about each device. We can normally get, say, a device name and a serial number, and also the device's protocol without needing to send any messages, any MIDI messages anyway, to the device itself. So to get all that static information that we know before sending MIDI messages, we've got this separate getStaticDeviceInfo function. And probably the main way you'd use this is to find out what transport a device is using under the hood, whether that's old byte stream MIDI or new UMP MIDI. To find out when the list of MIDI devices changes, you can just attach a listener to the endpoints instance. This should look pretty familiar to anyone who's used Juice and listeners before. So now we know about our devices, we know when they change. We probably want to talk to those devices. So the way we do that is we first create a session object. And a session, you don't need to worry about this too much. It's basically just a place to cache resources that can be shared under some circumstances between inputs and outputs. The important bit is you probably just want to create one session in your application and keep that around for as long as possible. You should avoid creating a session for each connection. There are more specialized use cases. For example, if you have like a multi-document application, like a web browser where you want a MIDI session per tab, that might make sense. But in the general case, you just want one session and to keep it around. Connecting to an input then is pretty simple. So we're just going to pass one of the endpoint IDs that we discovered earlier into connect input. And we're also going to pass this packet protocol flag, and this can be either MIDI 1 or MIDI 2. And all of the incoming messages from the device are going to be automatically translated to the protocol that you requested. And again, this is intended to reduce the amount of work that you need to do when you're writing your MIDI handling code. You just need to worry about handling MIDI 1 or MIDI 2 messages, and the framework will translate everything into an appropriate protocol automatically. To connect to an output, that's even simpler. We just need to pass an endpoint ID, and that's going to return this output object. The objects we get out of these functions, the input and output objects, are both RAII types, which means that if you destroy them, then that's going to release all resources associated with the connections. Of course, you might, the connection might go away before you expect it to. For example, if a cable gets unplugged or a Bluetooth connection gets dropped. So you can also find out if the connection gets dropped unexpectedly by attaching a listener to the input or the output object. If a device does get disconnected unexpectedly, then we're going to put these objects into a null state. You can check whether your connection is still active by calling this isAlive function, and that's going to return true while the connection is alive and false after it's disconnected. And also, if you initially try to create an input or an output and that call fails, then we'll just return an object in a null state right out of the gate. So you can think of input and output as behaving a bit like an optional or a unique pointer in the nullable, but they also have this sort of additional aspect where they might null themselves out if the connection gets dropped. So that's all the sort of common functionality between input and output. Now we're going to talk about the differences. So to actually get MIDI info out of an input, again, we're going to just attach a listener callback. So we say add consumer, and then our consumer function will receive a range of messages in UMP format. And as I mentioned earlier, all of the messages that you receive through this consume callback are going to be in the protocol that you requested when you opened the connection. Sending messages for an output, also you just pass a range of UMP messages. I'm just going to flag this iterator type quickly. So we use a custom iterator here because you might remember that each UMP packet might have a different length. They can be one of 4 different sizes. So this iterator is just responsible for striding through a packed array of packets with the right stride each time. And again, all the messages that we send to the output are automatically going to be converted to whatever protocol the device currently expects to receive. So that's pretty much all you need to talk to hardware devices. Next up, we're going to talk about the new virtual device API. So now in Juice, we can create 2 different kinds of virtual device. We've got a new full UMP endpoint, which is a full MIDI 2 endpoint. It's got 16 groups. It's bidirectional. You also have the ability to create legacy byte-stream virtual ports, which are your standard MIDI 1 ports that you know today. We've decided to go this route, exposing both options for backwards compatibility. At the moment, only the very newest platforms have support for virtual UMP. So in your new code, you're probably going to want to try creating a UMP virtual connection. If that fails, fall back to using MIDI 1 and then exposing reduced functionality potentially. So to create a virtual endpoint, we're just going to call this function, again on session. There's quite a few arguments here. Hopefully they're all fairly self-explanatory. In particular, we can request an initial protocol, which is going to be the protocol that the device starts out with. And we can also set a function block topology. That's the initial blocks argument. Again, this is an RAI type, so all the devices associated with all the resources will go away when it gets destroyed. And it also, again, has a null state like input and output. So on platforms where virtual UMP is unavailable, we'll just return a null virtual endpoint on failure, and then you can fall back to creating a legacy virtual port if necessary. To actually send and receive messages through your virtual endpoint, you can retrieve an endpoint ID from the endpoint object. This is a special ID that doesn't get enumerated when you list all of the devices through the endpoint's singleton. So you pass this special ID through to create input or create output, and this is going to create a totally standard input or output object that you can use like any other to send and receive virtual MIDI through your virtual ports. Virtual endpoints also have a couple of dynamic properties. So the function block configuration might be dynamic. So we've got this function to set a new function block layout. And we've also got a function to set a new name on the endpoint. So both of these changes, you can call these functions, and then the changes that you've made should show up on other connected UMP devices. So that's pretty much it in terms of new MIDI 2 functionality in Juice. I also wanted to call out that on our newest MIDI branch, we've added support for virtual MIDI on Android, which we didn't previously have. But if you want to support virtual MIDI on Android, you need to do a little bit of extra work compared to other platforms in your app just to make that all work properly. So the sort of backstory here is that virtual ports on Android are declared at build time instead of runtime, which means that we can't create them dynamically like we would on other platforms. Instead, the system decides when to open the virtual ports that we requested at build time, and then it will sort of let us know later on when it's decided to open those ports. Which means that our create virtual endpoint function might fail in the case where the virtual MIDI service hasn't started yet. So on Android, what this function is actually going to do is it's going to check whether the service is available. If it is, then it will bind to the port. If it's not, then it will fail and return a null endpoint. So we need some way of waiting for the service to start before creating endpoints. So we've got this extra callback on the endpoints object called virtual MIDI service active changed, which, as you can probably guess, will get called whenever the virtual MIDI service starts or stops on Android. So it's a good idea, if you need virtual MIDI on Android, to try recreating any virtual ports that you expect to have inside this callback. And if you do that, then everything should work as you'd expect. So to sum up, if you want virtual MIDI on all platforms, then the best sort of cross-platform approach that will work everywhere is to create all your virtual ports as normal, but be prepared that calls might fail. In the failure case, then you can additionally listen for this callback and create any ports that you expect to have active in that callback. Some of you might be a bit worried that MIDI input and MIDI output are going away. There's no need to worry. They're staying in place. So hopefully this change, fingers crossed, won't break any existing code. However, there is quite a big change under the hood for these types. So internally, MIDI input and MIDI output are now implemented entirely in terms of the UMP input and output, which means that there's automatic conversion inside. So we convert between UMP messages and MIDI 1 byte stream messages as appropriate. This process should be seamless, should be unremarkable, but it is a big change under the hood. So I'd like to encourage you, all of you, if you do use Juice and you're using MIDI inputs and MIDI outputs, it's probably a good idea to test out the new branch just to see, make sure that everything still works. Even if you're not using the new types, you'll still be exercising a lot of new code and helping us to flush out any bugs that are still present before this thing goes to master. And that's it. That's all the work we've done on MIDI 2 so far. I'd like to just flag a couple of potential areas for work in the future. So if there's demand from users and also support from operating systems, then we could look at some of the following. One thing that might be nice to have is a non-translating mode for inputs and outputs, because currently we always translate to a requested protocol on input and output, which might be wasteful in a few scenarios. Unfortunately, that's not possible on all platforms because on macOS, the platform itself will do the translation. OS level message, like timing information, is something we could look at. Reporting of more static device properties, such as whether the device is connected over USB or Bluetooth or some other transport. And also looking at adding a bit more flexibility around the number of virtual ports on Android, because at the moment, as I mentioned earlier, that has to be built in at build time. So I'd encourage you, if any of those sound good to you, or if you need some other feature that I haven't mentioned, please grab one of us and let us know. The entire Juice team is here, so you can make your voice heard. And there'll be some contact info at the end as well. I'm not going to go through platform compatibility in any detail. I just want to flag that a lot of these features are only available on quite new operating system versions, sort of released within the last 2 or 3 years. And on Windows, you will need to be running a developer preview build, and also you'll need to install the Windows MIDI services package for testing. I believe that situation will improve later this year. I think next quarter, this should start being bundled in Windows. We'll see how things go. So yeah, this is the call to action. Please try out this branch. All of the work that I've talked about today is available on our MIDI 2 branch. Because it is a big change, it's got quite a big surface area, and it's really difficult to test absolutely all of the edge cases. So please, if you're interested in using MIDI and Juice, please give it a go, even if you're using just the old MIDI input and MIDI output types. And if you're feeling brave and adventurous, try out the new stuff as well. Yeah, thanks for your attention. If you have questions or bug reports, that's how you can reach us. And as I said, the Juice team is here, so you can grab us and have a chat. Thank you.
All right, one more time for Ruben Thomas from the Juice team. Okay. All that MIDI 2.0 talk was making me hungry. Is anybody hungry here? Woo! I hear a couple woos. I'm hungry. So we're going to go ahead and have some pizza. So we got 20 minutes for pizza. And then after that, our next speaker, Christopher, will be coming on to talk about AI, all of our favorite topic. So go ahead, and pizza's in the back. Let's go eat and connect and see you back here in 20 minutes.
like a jungle sometimes. It makes me wonder how I keep from going under. It's like a jungle sometimes. It makes me wonder how I keep from going under.
Broken glass everywhere, people pissing on the stage, you know they just don't care. I can't take the smell, can't take the noise, got no money to move out, I guess I got no choice. Rats in the front room, roaches in the back, junkies in the alley with the baseball bat. I tried to get away, but I couldn't get far, cause a man with a tow truck repossessed my car. Don't push me, cause I'm close to the edge. I'm trying not to lose my head. It's like a jungle sometimes, it makes me wonder how I keep from going under. Standing on the front stoop, hanging out the window, watching all the cars go by, roaring as the breezes blow. A crazy lady living in a bag, eating out of garbage pails, used to be a fag hag, such a dance to tango, skipped the life and dango. A zircon princess seemed to lost her senses. Down at the peep show, watching all the creeps, so she could tell her stories to the girls back home. She went to the city and got so did it. She had to get a pimp, she couldn't make it on her own. Don't push me, cause I'm close to the edge. I'm trying not to lose my head. It's like a jungle sometimes, it makes me wonder how I keep from going under. It's like a jungle sometimes, it makes me wonder how I keep from going under.
My brother's doing bad, stole my mother's TV. Says she watches too much, it's just not healthy. All my children in the day daytime, Dallas at night. Can't even see the game or the Sugar Ray fight. The bill collectors, they ring my phone and scare my wife when I'm not home. Got a bum education, double-digit inflation. Can't take the train to the job, there's a strike at the station. Neon King Kong standing on my back, can't stop to turn around. Broke my sacroiliac, a mid-range migraine, cancer membrane. Sometimes I think I'm going insane, I swear I might hijack a plane. Don't push me, cause I'm close to the edge. I'm trying not to lose my head. It's like a jungle sometimes, it makes me wonder how I keep from going under. It's like a jungle sometimes, it makes me wonder how I keep from going under. My son said, Daddy, I don't wanna go to school, cause the teacher's a jerk. He must think I'm a fool, and all the kids smoke reefer. I think it'd be cheaper if I just got a job, learn to be a street sweeper. I dance to the beat, shuffle my feet, wear a shirt and tie, and run with the creeps. Cause it's all about money, ain't a damn thing funny. You got to have a con in this land of milk and honey. They pushed that girl in front of the train, took her to the doctor, sewed her arm on again. Stabbed that man right in his heart. Gave him a transplant for a brand new start. I can't walk through the park cause it's crazy after dark. Keep my hand on my gun cause they got me on the run. I feel like an outlaw, broke my last glass jaw. Hear them say, you want some more? Living on a seesaw. Don't push me cause I'm close to the edge. I'm trying not to lose my head. Say what? It's like a jungle sometimes. It makes me wonder how I keep from going under. It's like a jungle sometimes, it makes me wonder how I keep from going under. It's like a jungle sometimes, it makes me wonder how I keep from going under. It's like a jungle sometimes, it makes me wonder how I keep from going under.
A child is born with no state of mind, blind to the ways of mankind. God is smiling on you, but he's frowning too, because only God knows what you'll go through. You'll grow in the ghetto, living second rate, and your eyes will sing a song of deep hate. The places you play and where you stay looks like one great big alleyway. You'll admire all the number book takers, thugs, pimps, and pushers, and the big money makers. Driving big cars, spending 20s and 10s, and you wanna grow up to be just like them. Smugglers, scramblers, burglars, gamblers, pickpocket peddlers, even panhandlers. You say I'm cool, I'm no fool, but then you wind up dropping out of high school. Now you're unemployed, all non-void, walking around like your pretty boy Floyd. Turned stick-up kid, but look what you done did. Got sent up for an 8-year bid. Now your manhood is took and you're a make tag. Spend the next 2 years as an undercover fag, being used and abused to serve like hell. Till one day you was found hung dead in a cell. It was plain to see that your life was lost. You was cold and your body swung back and forth. But now your eyes sing the sad, sad song of how you live so fast and die so young. So don't push me, cause I'm close to the edge. I'm trying not to lose my head. It's like a jungle sometimes, it makes me wonder how I keep from going under. It's like a jungle sometimes, it makes me wonder how I keep from going under.
Yo, Mel, you see that girl, man?
Yeah, man.
Yo, that sound like Cowboy, man.
Cool.
Yo, what's up, money?
Yo.
Hey, where's Field and Raheem, man?
They upstairs cooling out.
So what's up for the night, y'all?
Yo, we can go down to Fever, man.
Go check out Junebug, man. Hey, yo, you know that girl Betty? Yeah, man. My mom's got robbed, man.
What?
Yeah, she got hurt.
What
bad.
just happened?
What the hell?
What's going on? Freeze! Don't nobody move nothing. Y'all know what this is. Get him up. Get him
Yo,
up.
man, we down with
Right them
Grandmaster
legs.
Flash and the Furious
Grandmaster,
Five.
what is that, a gang?
No,
Just
man.
hey, shut up. I don't want to hear your mouth. Shut up.
So what's the problem?
Ain't no you the problem. You the problem. Yo, you ain't got to get in the car. Get in the car. Get in the gas. I said get in the car.
Why is he talking like that?
And you said it was like
The sky's like a sleepy head, sleepy
Everything's going to this beat. Everything's going to this beat. Everything's going to this beat. Everything's going to this beat.
I don't know the name. Please don't say that I must know. And that's alright, I say. We're all getting through this our own way. I'd rather know nothing than all the lies. Just give me the person you are tonight. And we can make it work, but we don't know. We'll never hurt. It's you're strange, so you're perfect. You're strange, so you're perfect. You're perfect, baby. My perfect stranger. You're beautiful, you're worth it. You're the best, and you deserve it. You're a stranger, so you're perfect. You're a stranger, so you're perfect. I love that.
To start our next talk, please feel free to bring your pizzas back to the seats with you.
I don't know your friends or your ex's name. Who left
Come on down.
who took the blame. I don't know and I don't care. And that's okay with me. I don't wanna have the anxiety. Please don't say so I won't know. Don't say I don't wanna know. And that's alright, I say. We're all getting through this our own way.
All right, please take your seats. We want to get started as soon as possible.
Oh, we can make it work, but we don't know. We'll never hurt. It's you're strange, so you're perfect. You're strange, so you're perfect.
All right. Oh, can we fade the music? Are we ready to go? Okay, we're getting into our next talk. Everybody take your seats, please. Please feel free to bring your pizza to the seat with you as well. All right, our next speaker is Christopher Mitchell-Tree. So Christopher is a PhD researcher at the Center for Digital Music at Queen Mary University of London, researching deep learning for time-varying audio systems and spectrotemporal modulations. That's a mouthful. He is also a founding member of Newtone, an open source neural audio plugin, SDK, and community that helps bridge the gap between audio researchers and practitioners. In the past, Christopher has worked on machine learning and art projects on a variety of different companies and institutions, including Adobe, Google, Airbnb, A12, Spotify, and Cosmo. And his talk is on neural audio processing with Newtone. All right, over to you, Chris.
Thank you, Josh, for having me. Let me just check the audio here. All right, well, it sounds like the audio works. Do you want me to turn down this thing? All right. Cool, sorry about that. I guess everyone's awake now. All right, so I'm gonna talk about neural audio processing with Newtone. And today's talk will be quickly, my background, and then I'm going to give you a quick overview of neural audio processing, so specifically differentiable DSP, timbre transfer, neural effect modeling, and then a little bit about Newtone and how this relates to neural audio processing. So I only have 25 minutes. It's going to be relatively high level, but I hope from this talk you take away some inspiration about how machine learning can be used in an audio context in an inspiring and creative way. We're also going to go over how artists are using this technology as well. So quickly about me, I'm a third-year PhD student, and I study deep learning for audio systems. And I also was one of the founding members of Newtone. Specifically, I work a lot on the open source SDK, which is how you wrap PyTorch models to run in the DAW, but more on that later. So I think a cornerstone of neural audio processing is this concept called differentiable digital signal processing. So this is something I work a lot with in my research, and it's kind of a paradigm shift that occurred around, I would say 2020 is the most famous paper that changed a lot of how AI researchers work with audio. So basically, before the DDSP paradigm, we had kind of normal, what I would call neural audio processing, and it's very easy to understand. You have some audio, and instead of using traditional DSP functions like you would have in Juice or other frameworks, you run them through a neural network. And a neural network you can think of as just a function approximator. They're used all over the place for many different applications. And I think a very intuitive way to think about them from an audio point of view is they can be a filter, whether that's on a spectrogram or on a raw waveform. But kind of the paradigm beforehand was, and still is for some applications, is you take a neural network and you run it on some audio and get some new audio as the output. So this is used for source separation, which would mean getting the tracks individually from some mixed song. Speech enhancement, so removing the noise from your Zoom call, things like that. And audio effect modeling, so trying to create or recreate an audio effect. However, engineers, they solve problems with DSP, right? We have our well understood effects, and we want to be able to use them, like creating a mix. And so this is quite different from the traditional way of processing audio. So this is where this new paradigm came about, which is, well, why don't we use neural networks to, instead of processing the audio directly, why don't we use them to control the knobs that we control ourselves, but maybe they can control them in a way that's very efficient or very fast or in a new way, right? So the paradigm here is we take some audio, we feed it to a neural network like before, but we also feed the audio to some traditional signal processor. And then the neural network will predict parameters potentially over time or globally to process the audio. And if we make this processor differentiable, which just means you can calculate a gradient for it, which is how neural networks are trained, which most DSP operations you can do, you now have a very powerful way of manipulating audio that is different from the traditional neural audio processing. So the core benefit of DDSP is you can control audio effects, and you don't have this issue with neural audio, which is that it's a little bit unpredictable. So you don't always know what the output will be of the neural network. You might have artifacts, certain weird glitches. So DSP and DDSP specifically helps us kind of get rid of some of these problems. So one big thing is we get interpretability, right? So we can see what the neural network is doing to the control parameters of the DSP, and we can understand at least what is going on instead of having a black box where we have no idea what's happening. Another thing is if we don't like what's happening, we can intervene and control it ourselves because it's still human readable and still interpretable. So this is another really beneficial part. DSP tends to be really efficient because we've optimized it and made it really, really fast. And so neural networks are often very slow. And even though they run really fast on GPUs, in an audio context, we often want CPU inference. So efficiency is another big thing that DDSP can help us get around. And then high fidelity is also really nice because DSP, once again, has understood artifacts and can be used to reduce the artifacts of traditional neural networks. So that's kind of the main benefits of DDSP. So the reason I went over DDSP is because there's a specific application of it that is very interesting from a creative point of view. And this is called timbre transfer. It sounds a little bit silly at the beginning, but once you see some of the examples and how artists are leveraging it nowadays, it'll make a little bit more sense why timbre transfer has become a very popular creative tool. So the concept for timbre transfer is quite simple, which is can we convert some piece of music into another instrument or timbre? And many people, their initial reaction to this would be, well, why would I do this? I can just use a sampler or I can use a synth and create a violin or some instrument. But it sounds cliche, but it's often not the destination, it's the journey, and the process of transforming one sound into another results in some very interesting in-betweens. The other thing is you can do things that are very weird or don't really make sense. So for example, we can convert a violin into a flute. Sure, that might be weird, but it's not super novel. But you could transfer to unplayable sound sources. So for example, we could transfer your voice to the sound of a broken circuit or a telephone or an internet dial-up connection or the noise of a crowd in a stadium or some Foley sound. So you can be very creative with the source and the input. And then, like I said, the process of transforming one sound into another results in imperfections in between that have interesting sonic characteristics and result in some creative sound design. So the way we do timbre transfer with timbre transfer in general is with autoencoders. So an autoencoder is a neural network that is simply trained on its input. So you give it its input, and then it has to reconstruct it, and then it spits out the audio, and then we train it to recreate the same thing that was fed in. Now this sounds not that useful, but it is actually very useful because we often impose a kind of bottleneck here, like an information bottleneck. And so we force the neural network to learn interesting things about the input audio. So I think a really easy way to think about autoencoding is you're just doing a fancy form of compression. You're trying to make it smaller, and by compressing it, you're forcing it to learn parts of the audio that are important. So this Z is what we call it. It's called a latent space. Includes information about the music, the pitch, the loudness, the dynamics, and you can design these as a ton of PhD students and researchers that spend their entire research career trying to manipulate latent spaces and control them. This is a huge area of creative and of interest in this field. So then what we do is we train the neural network and we converge, hopefully, so that it's learned to mimic the input of whatever it was trained on. One thing that's really nice is it's easy to train this because you have labeled data. You're just trying to recreate the input again. This is another big problem in machine learning and AI, and especially with data and the ethics of where do you get your data from. It's nice to have labeled data that wasn't, didn't have to be hand labeled and gives us more options with training. And so once we're done training, what we can do is we can feed it a different sound, like a piano. And so this neural network will try to recreate the violin from the piano, even though it was trained on the violin. So if this input is close enough, and we found that there's a lot of wiggle room what you feed into here, or you can pre-process the piano to make it more better suited, then you can convert it. So it'll sound like a violin or something like that. So here's a quick example. I hope this isn't too loud. Let's see. So that would be the input into a model that was trained on a shakuhachi, which is a type of flute. And see, this model uses DDSP, and it gives you controllability over the breathiness and how tonal it is to create like kind of a really interesting part that you can control, which wouldn't be possible in kind of a traditional synth, right? But for example, you can use a different architecture like Rave, which can do non-musical outputs. So here's the violin again. And this has been fed into a model that does the human voice. Right, and so you see the non-musical applications of this. And this is just a very simple example. We found that artists have actually taken this technology and really pushed it to its limits to what is possible. One other benefit is this is done at 48 kilohertz, which in the past, a lot of neural network and audio machine learning related work was done at lower sample rates. So it's really nice to see some high quality audio coming out of these systems. I'm not going to go too deep into the architectures, but basically there's two very important ones that kind of are the foundations of a lot of future architectures. One is called DDSP. It's very confusing. DDSP is a concept, but their architecture is also called DDSP because they were the first to kind of coin it from Google Magenta in 2020. And this is kind of a synth that has harmonic oscillators and noise and reverb. And then Rave is the one more recent from Paris, Urcam, and this is another autoencoder that is less DDSP inspired, but still has some elements of it. And this is evolving very fast. So there's many other models. These are just kind of the two very famous ones that are the foundation. In general, if people are interested in timbre transfer, most people start with Rave or DDSP, and they have different advantages. Rave is much heavier and takes longer to train and is better for harmonic and percussive sounds, whereas DDSP is much lighter, can run in real time really easily, same as Rave, but even lighter. But its disadvantage is that it's for monophonic pitched sounds. And once again, there's a lot of people who have built variations of these systems for other use cases. So I think there's ones for MIDI and ones that are better for pitch and things like that. So I'm also going to talk a little bit about neural effect modeling. This is another big field with many papers and researchers that have worked on this. I shouldn't say big, but it's relatively large in the audio effect community. And if you're interested, we have a notebook with Newtone that lets you train your own neural effect emulation very simply, so you can learn how it works and how to do it yourself. It should require no code and no data, but you can use your own data if you want. But basically, the idea here is that we use the neural network to replace a conventional effect. So very simply, we take some dry audio and some wet audio, and we try to predict what the wet signal will be using the neural network. And once again, in the beginning, it sounds a little bit, what is the point? Of course, there's the kind of obvious use case, which is if we want to, mimic an audio effect, then we can do this. But what I find much more interesting is, the effects that are difficult or impossible to make using traditional DSP. So, a very obvious example is audio effect removal. So, for example, if you want to uncompress some audio, or if you want to remove reverb or things like that, this is obviously very difficult to do with a traditional effect, and so this is where neural networks become quite useful. Stem separation is a very common one for making karaoke tracks or remixing or things like that. I've seen effects where they split the track into percussive and tonal elements in an interesting way. And even something like style transfer for mixing is a big field where people are trying to build systems to help DSP engineers understand what's going on in a mix and how to convert it to another song. So if you're interested, check out the website, but you can see more at the SDK in a little bit. Very briefly, one way that you do this is with something called a temporal convolutional network. So many people have heard of neural networks, of course, and convolutional neural networks are used for images. You can also use them for audio in the 1D dimension, so signals. And one big problem is that audio, I shouldn't say it's a problem, but it makes audio quite challenging, is that it's very dense. So we have 40,000 samples for 1 second. And neural networks, they blow up very quickly if you're feeding them this many inputs. So one of the innovations here was the TCN, which basically has these convolutions that dilate, so they become exponentially bigger over different layers. So you stack the layers together, and the neural network looks at more and more samples in time. And it's a very efficient way to do this, such that you can run them in real time on CPU, and they can learn enough context to, for example, model a reverb, which might be a second long and requires 40,000 samples or something like that. So this is one of the underlying techniques behind some of these neural effect modulation, emulation networks. And the way I think about them is they're basically learning a very specific finite impulse response filter. That's one way to think about it. And then if you know about recurrent neural networks, RNNs, they're learning a very specific infinite impulse response filter. So the dilated convolutions, they increase very quickly. The receptive field is how long the neural network can look in time. And then you add a nonlinearity, like a tan-H function or something else, to introduce, to help it model. And this is also how distortion works a lot of the time with these neural networks. So yeah, and then you can use gradient descent to learn the filter coefficients over time in a black box manner. So it's a very nice way to model these effects. And yeah, you can check it out yourself on at the QR code. So all right, we've gone over kind of neural audio processing, and that's all great. But let's say you are a researcher and you've designed your own algorithms. So that's something I do a lot, is I build my own neural audio processing algorithms. And basically, Newton was born in late 2021, early 2022, because a bunch of us had different frustrations that came together. So Newton, the company, at its core, it's a company that builds tools for creative people. But we also bridge the gap between AI researchers and AI creators. So I was really frustrated that my models are really difficult to share with artists. So specifically, before at least Newton and some other tools that exist now, the way you would work to publish your models would be kind of like this. Like you would build a model, let's say in PyTorch, or one other neural network framework like TensorFlow or JAX. And then you train your model maybe for a day or for a week, whatever, and now you have kind of a frozen model with the neural network that's been trained. And so most computer scientists, they run the model on the command line and with some input audio that you want to use. And then you'll edit it in the DAW and take a look at what you're listening. So it's a very asynchronous process and very different from how practitioners and audio engineers and artists interact with audio models, right, and audio effects. For them, it's normal to have a plugin and run it in real time and have very quick feedback to see what's going on. So I was really annoyed by this, and we wanted to build something that made this much easier. So this is how the Newton SDK was born. This is what I am the most involved in at Newton. So this is an open source SDK for PyTorch that lets you wrap and export your models to C++ automatically without writing any C++, to then run it in the DAW using a host plugin. So the host plugin could be any plugin, but we provide 2 free host plugins to run your models. And so this SDK handles a lot of the pain that comes with exporting a neural audio effect. So if you are someone that builds a model, you would find our SDK, you would imported with pip in your development environment. And then you'd wrap your model and build it. And then you'll test it locally because we provide this host companion called Newtone FX, which lets you load the exported models. And so you would download the plugin, load that in Ableton or whatever you like to use, and then you can load the exported models directly in the DAW. And this is actually very magical because I can write, a line of Python code, export it in about 10 seconds, and have it running in Ableton and listening to it. So it lets me write Python and listen to it immediately in the DAW within a few seconds, which is very, was very difficult to do before. And then this is optional, but one thing that we really like is the community building aspect of it. So if you're happy with your model and it was trained ethically and passes, our guidelines for what we would want to share with the world, you can submit it as an issue, and then we will upload the model to the cloud. And so everyone who has Newtone FX, which is the host plugin, will see your model in the plugin browser and can download it and use it. So this is kind of how you would make your model and share it with the world. I gave a talk about this at ADC 2022, but basically building a universal neural VST is quite hard. When you use Newtone and the host plugins, it's supposed to be magical and just work. But under the scenes, a lot is happening because the DAW has a fixed sample rate and buffer size that can change at any time, and you have to worry about delay compensation and the CPU usage and controllability with these parameters. Whereas neural networks are kind of the opposite. They tend to be fixed and frozen once you train them. They've been trained on a specific sample rate at a specific buffer size, and that's it. So this is a bridge that needs to be gapped, and they tend to be very CPU hungry. So the Newtone SDK has this bridge it needs to provide. So it needs to guarantee that the DAW requirements are satisfied at all times, while the Newtone model, which is a neural network, also has to be satisfied with its requirements. So in a nutshell, it does all this automatic stuff in PyTorch, which then gets converted to C++ using libtorch, which is PyTorch's tool for converting their code to C++. And this means automatic sampling and buffer size selection, monostereo, delay, all these different things. We're actually releasing a paper about this coming out in a few weeks that has more details, but just know that a lot of effort went into this to make it work. And so this is what it looks like. You can tell us which parameters you want to use in your model, and then you can have different, this is the model browser with what other people have done. So for example, a shakuhachi, or we have one on Fallout or things like that. So yeah, Newtone FX is used by artists all over the world for timbre transfer, stem separation, audio effect emulation, spectral manipulation, and many different use cases. And I'll stress this in a second, but artists are kind of the main users of Newtone. A lot of them don't know about the SDK under the hood. To them, it's just a really nice platform for discovering some of these tools that are recently developed. We also have Newtone Gen, which is in beta. It's a non-real-time plugin. It's kind of like a sampler, and this removes the requirement for your model to be real-time, which was a huge barrier of entry because real-time is not always needed. For example, a stem separator can benefit from being non-real time, since you just press the button and get higher quality stem separation. And then we also made Newtone Morpho, which is kind of the commercial version of timbre transfer. It uses our own proprietary model to do the timbre transfer, and I'll just share a little video about it. And this will show you some use cases as well for the technology. Cool. So you can see, there's some interesting. Thank you. Thank you. Yeah, when I was doing my master's in Tokyo, I really wanted my algorithms to be somewhere with nice design. So, the team at Newtone was really good to team up with and make it pretty and beautiful. So I'm really happy how it turned out. But you can see some of the examples on the creative side. And we also provide a service that lets artists train their own models on their own data, which has been used quite a bit and resulted in some really interesting results. And lets artists kind of take over some of that power back to like use AI on their own data. I'd like to stress that Newtone, even though I come from the researcher and developer background, it's actually used the majority by artists from all over the world. We have a whole artist section, and I think it's really important to stress this, that it is an artist-first company, and we're really, really proud and happy about how we are engaging with the community. And so if you're interested in this, we have lots of artists that have reacted and enjoyed using Newtone. And for me, a big highlight was Arca actually using it on her Instagram. So that was a big deal for me. But yeah, if you're interested, check out the website. All the information can be found there. Newtone FX is free and lets you host your PyTorch models after exporting them with the Newtone SDK, which is open source. And we're also showcasing artists that use our tools. And in general, if you're interested in neural audio processing, you can check out my work. I'm christhetree.com or Frozen Mango or Chris the Tree on Twitter. But yeah, that's it. Thank you so much.
All right. Please give it up one more time for Christopher Mitchell-Tree. Okay, so we're going to go ahead and jump straight into the panel because we're running a little bit late. If you have questions for Christopher, please feel free to ask him during our break right after the panel where we're going to have some networking time. So what we're going to do is just do a little bit of setup up here. Please feel free to mingle for just a few minutes here while we go ahead and get set up. So see you in a few.
Need to call you.
Hello. We're pleased to have our panel this evening. The theme is What is Next in Music Tech? Emerging technologies are not only reshaping how creators work, but also redefining what it means to be a creator. This panel will explore the latest trends in creator tools, from AI-assisted music production to next-generation plugins and DAWs, and try to unpack what it all means for the future of music making. So over to you, Josh.
All right, so we're basically going to tell you what the next couple of years is supposed to look like, right? No, hopefully. All right, maybe one way that we can start is just with a brief introduction. So starting with you, Declan, would you like to introduce yourself and maybe a sentence or two about what you do and what your role is?
Yeah, absolutely. My name is Declan McGlynn. I'm the Chief Creative Officer at a company called VoiceSwap. We make high-quality voice clones for singers and producers to use in the studio. My background is in music tech consultancy and journalism with companies like Splice and Tidal, Native Instruments, DJ Mag, Resident Advisor, Music Tech, etc., etc.
Elliot Greenhill.
Hello, yeah, so I'm Elliot Greenhill. I'm VP of Product at Spitfire. If you don't know about Spitfire, we make premium, high-end, orchestral, cinematic virtual instruments. So go into the best studios, work with the best musicians, and turn that performance, that capture into a plugin, an instrument. As products, I look after sort of product management, as well as sort of looking at the vision of our product strategy and how we execute that.
And also a brand new father as well.
And that, yeah. Thank you.
Hey, let's give him a hand for that. Okay, Sarah Yule.
Hi, everybody. Nice to see you. I'm Sarah Yule. I'm the Managing Director for Orange Amplifiers. Hopefully you all know who that is, but we are around a 57-year-old company that makes beautiful bright orange guitar amps for professional musicians, aspiring musicians all around the world. I originally trained as a sound engineer many, many years ago, and I've spent the last 20 years in audio and music, mainly in commercial marketing, product and leadership related roles, but I've been proudly at the helm of Orange for 6 months now and really excited of how we are leading into the future as a fully independent, private family business in this crazy world we live in.
Thank you. And Mo Volans.
Hi, everybody. I'm Mo Volans. I'm the GM of Plugin Alliance and Brainworks Audio, which are essentially in the same building. What we do is we create our own plugins. We create analog models and all kinds of other plugins. We've got, literally 200 plus plugins in our portfolio with about 50 partners, and Plugin Alliance is our shop front for those partners. I head up both teams. And it's not my first time at Plugin Alliance. I was there for like 7-8 years previously, and I've come back now as GM, proud to lead the teams there. And it's a really exciting and fun position to be in. Previously, I was a music producer for maybe 15-20 years. I'm showing my age a little bit there, but and I went into journalism, much like Declan. Was writing sort of cover features for most of the mags, and then into product management and. Now an executive role, so it's a nice trajectory. But my office is still a studio, so I'm proud of that much.
What's better than that? Woo! Okay, so one thing that I love about this panel is that everybody's coming from a slightly different perspective. So we have consumer audio, we have distribution, right in the thick of plugins, and also from the AI perspective itself. So one of the questions I wanted to ask all of you was, what's one thing that you've seen over the past year that has impressed you, has intrigued you, that has scared you, perhaps? Any one of you can jump in.
I'll go first because I'm sat beside you. Well, actually, it's not that scary. Well, it is scary to rights holders. I think that one of the biggest things that's just kind of gone under the radar and is just completely fundamentally changing music production is stem separation in the DAW. I know that's not particularly sexy, given that it's not, not new. It's been around for a while, but since it's launching natively in things like Logic and FL Studio and and other DAWs on the way, I'm sure. I think we I don't think it's really dropped. This penny hasn't dropped about the impact of how that's going to change everything around sampling and the way we approach sampling and remixing. And if you think about, like, you know, it's in the MPC now as well. If you think about, you know, artists who would go, you know, sampling records, go record crate digging, trying to find these little snippets of samples from little drum breaks, and, you know, the Amen break being the classic example of that. But, you know, there's so many examples of artists who've, you know, they tend to rebuild them on YouTube and show how, like, Liam Howlett built this track using tiny little fragments and resampled them, pitched them down, put effects on them. And now, there's, you know, that's completely over. There's no requirement to find those little snippets anymore. You can just take anything. And the creative field, you know, given that you can sample from YouTube and Spotify, don't do that, by the way. And it means that you can have access to just every single acapella that ever existed, every single instrumental that ever existed, every single drum break that ever existed. And the creative implications of that, I don't think it's really dawned on people yet. And like I said about rights holders being scared of that, because, you know, it's going to be a minefield for them to now identify how those samples are being used. Because previously it was a stereo sample, and you could use certain technologies to detect that, but now it's completely changed the game.
Right.
I think that's really fascinating. Yeah.
I know one thing that's fascinating is that really impacts is in the dance world.
Yeah,
I mean, you
absolutely.
know, from your time, was it Future Music or Music Tech that you were doing?
Future Music and DJ Mag, yeah.
Yeah. So for anybody that doesn't know, Declan is actually a private celebrity, and from
That's news to me.
Yeah. So if any of you have ever watched the Future Music in the studio sessions, Declan was the person that was behind the camera.
That was me, yes.
So you were in the studio with pretty much all the big Avicii.
Yes,
You did
Avicii,
the
Martin
Avicii.
Garrix, Boys Noise, Lindstrom. I mean, you remember that, Mo, don't you? Mo was working at Future Music at the same time. So.
Wow.
Yeah. And then, you know, that there was a real art to sampling, you know,
Right.
and there still is, of course.
The kick drum is probably one of the biggest ones for dance music, right? Because kick drum is always the center for
Yeah, exactly,
EDM and house music, and getting the right kick drum. I know for me, when I used to produce house music, that used to be one of the biggest things, and
Yeah.
now that's a problem that's pretty much solved, isn't
Yeah,
it?
I think there's still artifacts remaining in stem separation, and that's maybe holding it back from being like a real, you know, it's not a pro audio solution yet, but like everything AI, it's improving all the time. And I think the Logic Pro one at the moment, I'm not sure what's powering that, maybe Audio Shake or something, but it sounds amazing. And it'll get better every version. And it's really exciting from a creative perspective.
Yeah.
But like I said, from a legal perspective, it's going to be very challenging.
Elliot, how about yourself?
Yeah, I think a positive one for me is, you know, looking at the sort of the DAW landscape, the plugin landscape, and just seeing that those two, where that workflow and that journey can be sometimes a bit clunky. What I'm seeing now more and more is sort of those two worlds sort of joining together, and those workflows joining together. You know, you buy a DAW now, or you get your free DAW. It's got everything in it already. It's got all your sounds, all your instruments, and so actually, a bad note on that is, you know, as for plugin companies, it's like, well, okay, you've already got everything. You know, why do I need to buy this plugin? And so, but what I'm enjoying seeing now though is the fact that there's more conversation, more partnerships now going like, well, you know, okay, if you want to have all that package within the DAW, let's work together. Let's bring that into that environment too, and actually with that solves the workflow too, and creates a better workflow for end users. So, you know, seeing sort of like everything, you know, partnership with like Presonus and Splice, you know, other examples like that, Pro Tools and Splice as well. We, you know, really bring in that sort of conversation, that interoperability between instruments, effects, DAW environment, and just merging that all together, I think really excites me, really.
Do you feel that it's all about ecosystems now, and that we've got all the sounds that we need?
I think we've got all this. I think there's always going to be inspiration and, you know, new ways of finding sort of individualism there, but I think, yeah, I think there's a paradox of choice, you know, when you look at all this stuff, you know, and so I think it's trying to make sure you sort of bring up the true value into that DAW experience there. You know, how many sort of compressor plugins can you have right now? It's a challenge, right?
Not enough.
A lot, apparently. Speaking of compressors, let's talk to somebody who is the head of.
Yeah, I
Brainwaves
mean, it's interesting listening to Declan because that, you know, AI first, your company, right? And we're definitely not. So we have a bit of a luxury to take our time a bit. Well, maybe, but we've been really cautious around AI because we think our customers quite cynical. Quite a lot of people are sort of automatically cynical about it. So we've got a lot going on in the background, but we're being really cautious about the play. But probably the most interesting things I've seen in that arena are large action models, working with agentive AI. So, learning somebody's profile, their habits, and then using large action models to, see those in action across multiple UIs. So, I mean, it's a really complex subject because there's so many variables. It's hard to implement, but I've actually seen some demos now of it working. And I think that this sort of workflow enhancement and really useful, practical uses of AI are what our customers, and actually a lot of the new customers, want to see. They, especially if they're sort of in the category of serious user or pro user, or they don't want so much of the creative process taken away from them. I think they want either superpowers, right, and augmentation and empowerment, or they want assistance, and they want to so they can trust their process. And then really quickly, another one I spoke to an investor about that I saw a demo of was sort of protective AI around protecting people's material with like invisible noise that it confuses AI for stem separation. So it's sort of like, flak and chaff for anti-missile defense or whatever. But for AI, my sister works at the MID, so I hear about it a lot, but probably not meant to say that. But, that's what she works with. So it's like anti-ordnance. So I think it's anti-ordnance for AI, which was a really interesting category for me. Protective AI and assistive AI, these are the things that I'll be sort of focusing on at first, I think. Yeah.
Like IP protection. Sarah, you're coming from a whole different side. So I'm curious if you've seen an impact in...
No, I mean, absolutely. I mean, I'm a big tech lover and a big nerd, so I'm going to avoid talking about AI because I see something every week. All I'll say on the subject is I'm delighted to see the amount of collaboration and ethics coming to AI and AI development in this year. That's been really cool. But I think to talk about sort of wider things that I think are cool around general sort of audio and music that's relatable also into hardware as well as software, I think it comes down to kind of three core things that I've seen a lot of development around. Firstly, kind of speed of processing for kind of embedded products and hardware, and just kind of what you can do on a chip now, like the amount of processing and the reduction in latency, I think is super impressive. I've just been having some recent discussions with some of the component manufacturers, and I think some of the technologies which are coming are really, really impressive that we're going to see in products next year and the years to come. I think the other thing is resolution. So I think, the quality, especially in consumer audio now, I mean, it's like a lot of the big companies now, when they're looking at kind of formats, you wouldn't have thought a few years ago that Bluetooth would still be so prevalent, but it's like the advancements in the codec there, the speed, the resolution which you can work in for consumer audio, means that a lot of these other formats, which are complicated for users to use, it can be expensive to integrate, take a lot of team and effort and stuff to manage, are actually becoming unnecessary. So it's been really interesting to see, and in consumer data and research, sound quality is still the #1 most asked for feature, even in kind of broad consumer technology use. So I think seeing that be something which is being focused on, which, for those of us that have been in the audio industry for a long time, the major consumer electronics side of things and chip manufacturers weren't always so interested in audio quality, and that was really difficult. So that's been great to see. And then I think the third thing for me is transmission. So in terms of being able to send and share signals at greater speeds, greater distances, greater quality, greater reliability. One of the speakers earlier was talking about Bluetooth dropout, or kind of things drop out, or kind of, some of the things you can do now in terms of, multi-channel, in terms of distance, in terms of transmission, and the stuff that's coming down the line, I think is incredibly exciting about how that can empower things, and in terms of kind of whole ecosystem thinking as well, between software, hardware, and usability in many different applications.
Right. And it feels like within the next couple of years, some of those things like true real-time collaboration within DAWs will be something that'll be unlocked. And that will be exciting, because that feels like it's something that I've seen happen within a couple DAWs and within a couple workflows, but I think there's a long way that we have to go yet.
There's a long way to go. I think anyone that's done any of those real-time sessions or in kind of wider things. Who's ever tried to sing Happy Birthday on Teams? But yeah, there's a long way to go. But I think definitely when you see the technology is there, I think we're just waiting for the wave of implementation, which is going to take another sort of, hardware always takes longer, and broader implementation by bigger companies takes longer because of their life cycles. So the technology is there. It's just going to take a little while for it to filter through and to get that wider adoption across mass consumer as well, and everyday musicians. And let's not forget, like, musicians and consumers are really conservative and generally don't necessarily understand why any of this stuff is important. It's like a lot of people in this room, we could identify as nerds, and that's fine. There's no shame in that, but not everybody is like that. So some of this stuff is really cool, but no one needs it. They don't think they need it. They don't know why they need it. So it takes a little bit of time for that to filter through and become something that's actually relevant for people. And I think relevance of all of this technology has got to be the number one important thing.
Yeah, absolutely. Did you have something you wanted to say, Elliot? You look like
No, just when you're talking about transmission, yesterday I was talking to a colleague. We do big recording sessions. That's what we do. And a colleague of mine was mixing and giving critique or producing at the office while we were mixing in Italy, and like things like Audio Movers just completely opens up that possibility now. And we wouldn't be able to do that a few years ago. And now it just creates so much flexibility around producing and engineering just within sessions.
Absolutely. And speaking of collaboration and creation, I had this question originally for Declan, but maybe I can open it up to anybody who wants to answer, is about the next generation of creator and how the definition of a creator is changing. And just wondering if any of you have any remarks on that, now that we're seeing some new workflows for music creation. Is that going to replace our traditional ways of making music, or is it going to be augmented, or is this a new stream? And I'm wondering your feelings about this.
I'll jump in really quickly. I think that we've got plenty of buckets for our ideal customer profiles and who they are and personas. I mean, like everybody has. But you could probably put it into two really broad buckets, and that's the enthusiast and the pro sort of bucket. And that's the one I was talking about before, that they're quite cynical and have their, even if they're younger, or age doesn't seem to really matter, they're influenced by their peers, and it's trickle down, and it's like what everybody else is using and what the pros are using. That world is quite small. It's the world we mainly work in. And then the other world is the prosumer, consumer content creation market. And it's, I've worked in video as well, and it's massive. I mean, it's huge. It completely dwarfs the total addressable market, dwarfs, completely dwarfs anything in pro audio. And I think that the values that they have are so different. They want things fast, they want it free, they want it now, they want it yesterday, and they don't really care. I mean, I'm generalizing massively here, but they don't seem to care how it's achieved, right? They don't seem to mind, because they're probably not musicians on the most part. They probably don't want to spend their 10,000 hours or whatever it takes to, I think a lot of us are in love with the process, and we love the process, whether it's coding, whether it's music making, or both, or everything. And we all love that process, but some people don't, and some people just want the result. And you sort of can't ignore that, because it is a part of the market. And just because we might not, identify with that as much doesn't mean that they shouldn't be addressed and sort of catered for. So we're really thinking about that moving into next year. Like, what does that look like? What do audio tools for them look like? And a lot of people are catering for them, but it tends to be inside sort of nonlinear video editors. And, it's not, the door is still really catering in the most part for the music creator, the enthusiast and the pro. We see from our plugin data that a lot of them are using it 9 to 5, Monday to Friday, right? So we know they're working, but what about the rest? What about everybody else? And I think that, that's a really interesting part of the market for me.
I think that kind of relates to something I'm thinking, because I think it's all about the interface as well and the interaction. I think at the end of the day, you could get into some deep conversations about what does it mean to be a creator, or what does it mean to create. But I think throughout time and history, it's always been about a interaction between a cause and effect, right? So, when it was, banging a drum, throughout history. And if you think about some of the coolest instruments through time that have really revolutionized things, like I spent 5 years at Akai, and if you think of a product like the MPC, that was because it was easier, better, and faster to produce on an MPC than it was at the other technology at the time, because of the way that it worked as a system. And I think that easier, better, faster is always relevant. There's a lot of people in this room that are ex-colleagues of me from Rowley. I was at Rowley for 4.5 years. When the Seaboard came out, it was about trying to make music production easier, better, and faster by something that was super intuitive to work with and play with. And I think throughout time, any time that you create a beautiful handshake between hardware and software and make the creator able to do something easier, better, and faster, that's when you enable them to create better. And I think it doesn't matter if the way in which we're creating is changing. I think what we need to think about and we need to address is, what does that handshake look like? What does that interaction look like? Because the DAW, let's not forget, most DAWs are still based on a tape machine. That's kind of what they're based off, is a tape machine. It's super old in terms of a format. And we're now creating these new tools, and we're trying to use the same hardware, the same interface, the same thought to control them. And I think that's what I think is going to need to change, is the way that we interact and how we look at things. But I think there's always going to be that need between cause and effect and an input device, and the human element needs some sort of tactile element to it. It can't just be a visual stimulation. It's a sensorial experience to create. So I think that's what's going to be important. And I found it really interesting, actually, this year when, not asking you how you feel about him, but Sam from OpenAI said, that he feels the future of the company is all going to be about creating new devices, in terms of the only way he thinks that generative AI will not become just commoditized is to find the right way to partner with hardware. And I think there's an important lesson in there in terms of how we're thinking about new tech and how we're thinking about how that integrates with the essential pieces of hardware that will stay with us through time and enable more people to create.
Yeah, that change that you've both been talking about, that was actually, AI gets credit or discredit for a lot of disruption, and it certainly is disruptive, but that need for change and that split in the market came from the pandemic, really, because a lot of people were at home and they had time off and they were, bored, and they were like, oh, I've always wanted to learn how to play the guitar, or I want to, had piano lessons when I was a kid, and then, and the instrument sales went through the roof, and I think Ableton had a 3-month free trial, and Logic had a 3-month free trial. And then you get these people who are coming to it from a completely different perspective, like Mo was saying, where they're not particularly interested in mastering the tools, they just want to get from A to B as quickly as possible. And then a lot of acquisitions happened, Native acquired Brainworks and Plugin Alliance, Pioneer tried to buy Serato. There was in music bought Moog, and so there was so the market was changing, and there was a real conflict there between the legacy tools, which are the DAW based on essentially tools from the 1960s, and what people who use Canva expect from their music experience. And there hasn't been that Canvaization of music making tools. You could say something like BandLab, perhaps, and now DAW companies are being forced to kind of, where they were, I wouldn't say they were lazy, but they were a little bit complacent in the past. DAWs are based on very legacy code bases, a lot of them are from the 90s. And so then plugins filled in the gaps. You had the innovative plugins layered on top of DAWs, but DAWs themselves were quite, old school. They're fully offline. You don't have that Google Docs style collaborative experience. So anyway, where I'm going with this is that disruption was happening pre-AI anyway, and there was a little bit of movement happening, but AI has forced these companies to kind of rush forward a little bit faster. And I think what we will see now is it's going to bring DAWs into the cloud finally, which is, where it should be anyway. They're so crazily offline. But most AI tools are cloud-based. So it's going to, and FL Cloud is a thing now, but they're more than a little bit behind on that. And I think we're going to see some innovations around that. That's how the workflow will change.
Do you think that? Go ahead, Elliot.
I was just going to add to that, post-pandemic as well. I'm sure we've all seen a pitch deck with the term democratizing music, right? And I still don't think we're there yet, right? And we're all after that, larger total addressable market, but I don't think that tool's there yet. In post-pandemic, right at the beginning we talked about flow state. People starting wanting that sort of Canva style experience, but I don't think it exists yet. There's too much frustration and too much onboarding to get into working in your traditional DAW, and I think that's where the next step will be really in terms of really democratizing that.
Yeah, I think that's going to be, you probably hear this from some of your vendors, Mo, like, how do you appeal to both those worlds and keep one foot in both without it being so simplified that you put off the pro users, and without it being so pro that you put off the beginners or the...
No demographic, but nobody likes it.
I think we have to remember with all of this, though, I think there's a reason why. I mean, who's got kids in this room? I've got two, one that makes me feel really old and one that makes me feel even older, but there's a reason why when a kid is starting to play an instrument at school, they are playing a recorder or a ukulele or a drum. You pick it up, you do something, it makes a noise. There's an immediate response, there's an immediate reaction, and it feels good. It makes the kid feel like they were in control of something. They did something, they had that cause and effect and that immediate response. As far as I'm concerned, a lot of these digital tools, they're cool, they're fancy, they look nice, you can do some amazing things, but none of them for me yet are as simple as it is to pick up a ukulele, a recorder, or a drum and make a noise and make yourself feel good. And I think until we get to the point where we're creating tools that feel that easy and that interactive and that immediate in their response, we haven't cracked it yet. And I think we need to look at the world like a little 5-year-old sometimes and to understand what we need to do to really democratize music. And it's not about just making things cheaper. It's about making things that make people enjoy the process and enjoy creating.
Yeah, a lot of the tools that a lot of your customers will probably just made their decision about AI being awful and being cynical about it are those end-to-end tools that are just prompt-based. They take away the actual fun part for most of us. What we've been doing at Voice Swap is really thinking about how we inject ourselves into the existing process and just solve one problem, rather than, because we have a VST-AU plugin as well for that reason, because we don't want to take people away and put them into the browser. We want to say, because a lot of AI tools are in the browser, we want to say, you're already in your, you can combine it with existing plugins. We just solve this one problem for you, and you stay in your flow state, which is really important. And a lot of AI tools haven't cracked how to allow people to stay in that flow state, partly because of the restrictions of DAWs and cloud-based AI tools. But yeah, that's something that we're always thinking, the utility of this. Right. It doesn't matter about the tech. It's like, what problem are you trying to solve? And how can you do that as quickly and easily as possible?
I was lucky enough to get a 6-month research grant on this subject, and I did it as I joined PA. And so I spoke to a lot of artists as part of that, and pretty much all of the artists unanimously see that process as sort of sacrosanct, as something that shouldn't be interfered with. But they do want help with mundane tasks, and they do want to feel empowered and given augmented skills. And I think that's what Voice Swap does, right? And I think that what they don't want is their creative process to be replaced. They just want everything else. They want help. We're finding that these forward-thinking utilities, there's even non-AI forward-thinking utilities. We've got one coming out that takes a hearing test and gives you a corrective EQ based on any hearing deficiencies you've got. Before we signed it as Brainworks, we sort of ran some product market fit tests on it and sold it for a few days, and it just went through the roof. We sold out of codes, we sold out of plugins, and it was so we ran it again, and it did the same. And we're realizing that these are the tools, these utilities are the tools that people need. They need it to sort of find that they can trust their process, that they can, because they're not with people, they're full stack creators, right? So they're in a room by themselves probably. This is why something like Metric AB that we sell has been so popular. It's just a comparison tool, but it's on everybody's template, and these utilities are sort of the thing that seem to be really help. They don't want 1 billion more compressors and EQs, and we'll make them anyway. But no. But they don't. We genuinely they don't want it. So next year we're thinking, okay, what do people really need? Not what they not need, and we can convince them they do. Because I think for a long time, companies have been doing that. They've been convincing people that they need something. Come on, it's really good.
Yeah. The plugin market is specifically good at FOMO.
Yeah.
More than any plugin marketing is pretty much all based
objects
on
of
FOMO.
desire.
Gas.
Yeah, exactly.
It's like the shampoos, isn't it? It's like coming up with all of these things of why you absolutely have to have it. But we still fall for it, right?
Oh, every time.
Do you feel that our interfaces that we interact with, which are primarily a mouse, are those limiting? Do those need to go further in order for us to be able to get that immediate creative dopamine hit.
How long have we got? Yes, is the answer.
About 15 minutes.
The mouse and keyboard are like, I think it's one of the most limiting aspects of how music is made, and it's kept the DAW from being innovating also, because it's kept it very point-and-click based, which is not a creative process. And many controllers like Rolly have innovated and tried to solve these problems in the studio, but I do think the cloud-based aspect, where there's a company called Bronze.ai, you might know them. Lex from Bronze is fantastic, and they were with Richie Houghton and Arca, and they did stuff at A24, and we had this conversation after a sip of beer, right, UI. And it's basically, will AI change user interfaces in a way that, if you're training a model and, you're talking about, you're learning someone's workflow, and then you can assist them when they're a bit hungover or they're tired, and they just say, do what I would usually do to this kick drum, right? And that's a cool utility where you're still in control, but the AI is helping you. What if the UI was, it was adapting to the way that the kind of actions you were completing the most across the DAW, and the DAW slowly changed over time to make that process easier for you, because you're always going into this menu, and then, okay, well, you're always right-clicking this and changing this, so let's just put that front and center. And all this kind of dynamic UI concept is really interesting. And maybe it's a little bit too confusing if things keep changing all the time, but there's something there for sure that I think is really fascinating around how these tools look and feel, and if they become dynamic and personalized, then everyone's going to come at it in a different way, which they do now anyway with every DAW, right? Everyone approaches things differently, but I think that's a really interesting concept. It's a little bit more conceptual.
What do you think, Mo? You must know a lot about this.
Well, a friend of mine that I went to school with runs Vision Pro, so it's like we've been having a lot of conversation. He's like, build something Vision Pro, and you'll get you on the stage at the, because nobody's doing it, and nobody's really made a great environment to make music in VR, AR, and I think there's a reason for that. I think it's because nobody really wants to wear the headset, and nobody wants to pay $4,000 or whatever it is. I said, well, give me some headsets. He went, we don't do that. So I was like, not going to go and buy them. But I saw something really interesting, something else interesting about Apple, and it was like, I've got the new beta. I don't know if anybody's got the beta of iOS 26. Don't download it if you haven't. But it's not ready yet. If you want your phone to run out of batteries, mine is now. But the control sort of center it seemed blurred. It's like liquid glass, they're calling it, right? And it sort of looks a little bit unclear. And I saw a really hot take on it. Somebody said they're getting you ready for something else. They're 5 steps ahead. It's unclear so that you get used to seeing things through unclear elements, because augmented reality is coming. And they're going to, I love this about these takes where originally it was like, these are finger shaped because it's going to be touchscreen, and they're going to do it they're going to make Macs touchscreen, so everything is being prepared for you. So there's no big shock, there's no moment, there's no watershed moment. And so I think that we're heading somewhere. Apple seem to know exactly where we're heading. They'll probably lead the charge, but I think we need to think about it. And I think that Declan's right. I don't think it's mouse and keyboard, but you can try and pry that from my cold, dead fingers.
Well, I think voice. I think voice will become a huge part of it.
Absolutely. Yeah.
And we think about that a lot, and we've been developing a separate product actually that's specifically based around this voice control of DAWs. And it's partly paired with agentic AI, but it's just saying, stem separate this clip for me. And that's not taking away your agency, it's just a different way of interacting. There's limitations around natural language. I mean, my sub bass is different to your sub bass, so like how do you process subjective terms? And again, maybe that's around, it learns about your taste over time. But yeah, I think voice and the studio will become very united, as if you've got an engineer sitting beside you. But I
think that's it. I think that assistant, literally not just assistive, but an assistant. Vocal comping or whatever it is, those long mundane tasks that people literally get paid for. If any job goes, it's going to be that, because I think that's what people want.
We're so used to that in everyday life now, though, aren't we?
Sitting on your own, talking to yourself.
Yeah. You know me. No, but Alexa, Alexa in the kitchen, all this kind of stuff. It's only
ChatGPT now,
yeah,
right? I mean, you have a conversation. Yeah.
So it's only natural. It's just going to feed into your professional workflow too. And just going back to sort of keyboard and mouse, I think something that is silently growing, I think, is
sort of the mobile music making scene, you know, a bit more immediate than sort of everything else we're talking about. You know, an iPad no longer is just you know, an unpowered mobile device now. It's, you know, it's got the processing power, you've got the storage capabilities, and you know that immediately takes you away from you know, the keyboard and mouse. I'm hearing more and more people and peers sort of, you know, get primarily using Logic now on the iPad as their main door. So yeah, I think that's going to grow even more really.
I'd love to hear your
plugins are so easy now to you know, deploy on that platform too as well. So.
I'd love to hear your thoughts, Sarah, from a hardware perspective. But before I do that, I wanted to interject really quickly because one interface observation that I recently had was that that made me really think about what we're doing in the music space is something completely outside of music, which is that recently I got a pair of Meta glasses, and just the simple act of taking the camera from my phone to recording from my glasses psychologically feels completely different. I'm very self-conscious if I'm at a concert or at a live event and I have my phone with my camera in front of me. But switching that just to the glasses and just pressing the button doesn't even feels completely different then. And I'm wondering if we're waiting for those types of moments in terms of music making as well. But I wanted to ask Sarah, coming from a hardware perspective, do you find that people are satisfied from your consumers are satisfied with the interfaces that they're having, or are they searching for more? Are they searching to have new ways of interacting?
I mean, I think it's slightly different because, you know, predominantly an Orange Amps user, an Orange Amps fan is a guitarist. So you try telling a guitarist that they don't want to play with a guitar anymore as their main. You know, it's a slightly different thing because a guitar is a beautiful kind of piece of art that's also super interactive and makes some really cool noises. And I think it's almost a separate niche. So we're seeing more people coming to guitar. Obviously, everyone saw the growth during lockdown when everyone was at home doing a million different hobbies. But, you know, we're continuing to see that. I think, you know, a little bit like the kind of vinyl resurgence and the desire for people to kind of have physical, tangible things that they interact with. I think at the same time, we're seeing all of these developments in terms of technology and apps and, you know, kind of in the box, as it used to be called. We're also seeing people that really want to pick up something tangible and make some noise. I just want to make some fucking noise. Do you know what I mean? And so I don't think that element's going to go away. I think the interesting challenge for me is thinking about the broader piece of, well, even a guitarist is not just playing all the time. They're not just performing. They're practicing and they're also interacting. And their piece of art needs to then interact with a wider ecosystem. So maybe sometimes they're composing, they're producing, they're interacting with other players. So I think the challenge for us is to understand how our hardware can remain relevant. Now, in some ways, it's super easy for us because we are fully analog. We actually made the first ever digital guitar amp in the early 70s, and everyone thought we were crazy. They thought it was still the 60s, we'd been smoking too much, and they're like, what are you doing? Why are you making a digital amp? We're a bit ahead of the curve. But at the moment, you know, we're mainly an analog company, but I think the future for us is thinking about how we can sit and stay relevant in that broader ecosystem. And I think that's going to come around thinking about how we can make it really easy for our products to interact and be part of those ecosystems. I think it's about finding meaningful collaborations and ways of working, because music world is a huge ecosystem from the point of creation through to the point of consumption. So I think we have a legitimate need as an industry to work together and to collaborate to kind of help protect that and help people through that whole journey of how people interact with everything. So I think, you know, we're talking very much about music technology, but the whole industry is a little bit broken and defragmented at the moment. So I think the more that we can do to work together, and I think that's how we can stay relevant as a hardware, is understanding that we are just a part of this broader ecosystem, but there's ways in which we can ensure that we're making it easy for our hardware to integrate. We're thinking that our ecosystem is beyond just us as a brand. The world is much bigger than us as a brand, and it's about finding those meaningful collaborations so that our users feel like they're investing in something that really can last a lifetime for them and inspire them every day.
One question that I had was around the experience level of your consumers. This is probably difficult to measure, but what's your consumer demographic in terms of people that buy your products that don't have relatively little experience with guitar amplifiers?
I mean, it's difficult to quantify because I don't actually have data. So this is just going to be hypothesis based on hearsay and a rumor, which is not very scientific. But the demographic is pretty broad. I would say on the guitar and bass amp side of things, most people that play and use Orange amps do have some experience or are kind of more players. But I think because the amps are so bright and colourful, because they've got a great reputation, and it's a bit like if you're getting into mixing for the first time and you go and you learn on like an Audion desk, it's great because it's a traditional analog inline desk and it's really easy to understand signal flow and routing and everything. And I think it's the same with an Orange amp. It's not full of buttons and menus and different options. It's like you switch it on, you plug in, and you sound fucking great. And I think that's really inspiring when people are also at the beginning of their journey. But you know, outside of just the amps side of our business, you know, obviously we've got Bluetooth speakers. We've just done a turntable, a UK-made turntable this year, as a little throwback to when we used to have our own label and press 7 inches in the late 60s and 70s as well. And for those users, we're seeing that is people that go out to gigs or festivals or interact, but you know, they're necessarily not guitar players. Some of them are just super fans, but a lot of them are just music people that kind of want to buy into that ideal, but with something that feels authentic and real and fits into their life. So now the challenge is thinking about, okay, in that wider ecosystem I was just talking about, how can we create kind of a sort of beautiful pathway between, you know, those people that are kind of practicing and performing through to kind of that playback area as well, and create a beautiful kind of life cycle between it where people feel that they can kind of interact with all of these elements again from that point of creation through to the point of consumption and background again. So I think as a hardware company, there's certain advantages to that, even in a changing world. Although hardware can be tough and it can take longer and it takes more investment, it's a real tangible thing, and you can create desire around it. So it's not just something that people need, it can be something that people really, really want. And I think that's important. You said at the beginning something that we're really excited about, something we're really scared about. What keeps me up at night is the fear of the complete commoditization of the music industry as we know it. And that sounds a little bit, but you know, if making music, creating music, releasing music, distributing music, you know, on all sides of the industry, people are concerned about how AI or technology is replacing things and taking away potential for revenue streams. If getting a piece of music becomes the same as being able to choose a light bulb on Amazon, like you don't need any thought for it, there's 1,000 different options, it's like super easy. You know, there's no fun in it, and I think, you know, we have seen backlash against companies which come out with statements that make it seem like that's what people want, is a complete commoditization of the industry. We absolutely do not. Nobody wants that, nobody needs that. You know, music and art is a science, it's a beautiful thing, it's a meaningful thing, and it should be about desire, and it should be about emotion, and it should be about irrational feelings, and it should be about unpredictable mistakes turning into beautiful pieces of art, and it should be about collaboration and community and all of these things. And I think with a hardware product, it helps people kind of tether that into something tangible and real. And so I do think hardware companies have got a real job on their hands to, again, collaborate and work and help to fight for the fact that this is an industry worth saving, and there's lots of things that we can do to continue to inspire and have music and arts as an important part of our community and our society for our future generations as well.
Absolutely. Maybe that's a place where we can start to wrap up, is something that we're looking forward to, something that we're concerned about, or something that keeps us up at night, that we're intrigued about. So yours is music commoditization.
Yeah, my thing that keeps me up at night is the commoditization of the creative world. Yeah.
Right.
And fighting against it. I'm going to start wearing my pants over my trousers. Fight against it.
Mo's still thinking about his, I can see. Elliot, something you're looking forward to, something that's concerning you, something that you're excited about?
I think what concerns me and what continues to drive me is continuing to make
amazing products that really give value to our end users. You know, we all know the industry is struggling. It's harder to, you know, get gigs, get jobs. It's, you know, I think there's also distractions in your wider world, even if you're a hobbyist. You know, money's even hard there too. You know, I think there's compromises to make on buying your next favorite plugin or music product to, you know, utilities you have to pay, you know, at times. It's a struggle. So I think we really need to focus on bringing value and bringing uniqueness and products that make people stand out. And so I think that's both a worry for me, but also a drive of making sure that we continue providing that and could provide value for our end users.
Bringing joy back to music. I like that.
Yeah, I mean, kind of combining both those things, but we spend so much of our time, and have since day one, focusing on solving the AI problem of attribution and compensation for artists in the age of AI, which isn't going to go anywhere. And very early on, from 2023, when we started the company, we paid artists royalties at the point of inference, which means as soon as the voice is converted into their voice, they get paid a royalty, even if the track never gets released. And since then, we've innovated in other ways, like a partnership with BMAT, where we scan all of our training data to make sure that there's no copyrighted content in there, so that when you use our models, you know you can use them safely. We do the same thing when people create models on our platform, so they can upload Beyonce acapellas. So that means when they're fully compliant. And I think we think about this all the time. Like Osrin, our CEO, is in the audience here. She spends time in Westminster lobbying the government. It's a full 360 effort. It's not just building a tool that's cool for producers to use. It's like, if we're going to give this to people, we need to do it safely, and we need to do it responsibly. And that is something that we feel really strongly about. We're a team of people from the music industry. You know, my background, I worked at Point Blank with JC and the guys here, and also worked at Future Music and DJ Mag, and I've been around the full circle of reporting on the industry, consulting with the industry, being in the studio, hey. And, you know, and understanding that 360 thing is spotting this new trend, as it was back then, and turning it into something meaningful. And being able to say another way is possible in the age of AI. It doesn't have to be about exploitation of artists. It doesn't have to be about scraping data, creating these models, monetizing them, and, you know, telling the artists, you know, they can do one. And we can coexist. And there, you know, there's still a lot of work to be done on that front. But, you know, I think, Sarah, you mentioned the rise of the conversation around ethics in AI. Has been great to see. You know, back in 2023, it was a Wild West. You know, that term has become a little bit cliched, but it was a Wild West. No one was talking about this. Everyone was like, look at this cool thing, look at this cool thing. And it's like, how did you train it? Whatever, don't worry about it. You know, slowly people are waking up to that. And that's great. And we want to see that. But businesses have to take that seriously as well. Not just the audience understand that it's important for them to support industries that is also their livelihood, like the music industry. They can't just exploit it and then expect to have a career in it at the same time. But as it's up to all of us and other companies to create safe platforms for people to experiment with technology, whether that's AI or not. And that's, you know, that's what gets me up in the morning every day to try and find a way to do this as seamlessly as possible. Because if your platform is super safe and it's all legal, but it's the slowest and the worst to use, no one's going to use it. So you have to be both innovative in the back end, from the rights perspective and the legal perspective, but also innovative in the front end and on creating tools that are not only legal, but better than the illegal ones. And that's how you're going to win as well. And that's the only way it can be done.
Helping humans get paid. I like that.
Absolutely, yeah.
Mo, let's wrap up with you.
Yeah, so I've got a colleague, and I was talking to him about this whole picture, you know, the challenging industry, AI, whatever, you know, all these new tools and the way people are using things. And he said something along the lines of, I'm going to surf the wave rather than be swept away by it, you know. And I think that's a really nice way of putting it. I think there's a massive opportunity. So next year, I've got this sort of, we've got this luxury of looking at our roadmap and saying, well, you know, we can do the obvious, we can do the thing we've always done, or we can sort of go back to the drawing board and say, you know, what is it we can do? And being at NAMM most recently, the collaborative attitude of all the brands was really, there's something changing, and it's probably the challenging industry, but I think it means that like Declan's saying, there's a lot of responsibility for us to look at all the tools and say, because, you know, we're looking at React and Electron, and we're looking at, you know, TensorFlow, and we're looking, we're really thinking about what does it look like? What does the next thing that people really need and really want look like? And again, not trying to sell them something that they don't need, right? I mean, this has gone on for too long, and we've been guilty of it, and I think that a lot of people have been guilty of it. So, yeah, I'm just looking forward to next year. I'm looking forward to what we can achieve and what everybody's going to do, because I think there's cool stuff on the way, honestly.
Absolutely. We're better together. Great. All right. So we're going to wrap up here. Please give it up for Declan, Elliot, Sarah, and Mo. All right. We don't have any time for questions. No. If you want to ask them questions, please feel free to do so right now in the networking hour. So next hour or so, we're going to do some networking. So we're finally free from talks. Please give up a hand for all of the speakers, all the panelists. Thank you so much for coming. Also, once again, would like to give a big shout out to Point Blank and our sponsors for making all of this possible. Thank you for coming out. Some of you have come from very far. And we wanted to make sure that we had some time at the end so that we could connect with each other. Once again, we have a wide variety of people that are here in the room. Please feel free to come up to any one of these panelists or anybody here in the room, and please connect. Let's connect with each other. Use this time to make new connections and keep this industry together. We're going to be okay. All right, everybody, have a great evening.